All right, how's it going? So we're gonna be going over the discussion that Jeran and Dell had. We'll just be highlighting the logic that's used. Again, we're not gonna be picking a side. We're just gonna listen to the conversation unbiasedly and just go from there. I did watch this conversation before when it was live. I will post the link in the description right now, I guess, for the original live stream for people that haven't seen it. Um, so I'll post it in the chat, and yeah. So let me go ahead and get it started. Give me 1 second. Let me screen share. Audio, yes. Okay.
Should I let it practice?
Right. No, yeah, that's good. Okay. Is the audio good? I guess if the audio is not good, just let us know in the comments, and we'll check it again. But okay, we'll get it started.
Yeah, can you be a little bit? Can you turn your volume up just a tad? I think you're coming in a little bit soft for me, at least. Let me. I'll do it. I'll just make it a little bit louder.
I'll switch my camera off since nobody
yeah.
else.
Yeah. Go ahead. Go ahead, Del. I just need to take a 2-minute break real quick, but go ahead. The floor is yours, Del.
Wait, you're gonna take? Oh, you mean you're gonna take a 2-minute break on your own? All right, I gotta pee when I get a chance to. Go ahead, Del.
No, wait. If you want to go for a pee, Jeranism, I'll wait.
Yeah, let me do that real quick. Let me just pee and I'll be right back. Yeah?
Cool.
All right.
So while I'm here myself, there seems to be a lot of focus on, visual interpretation. Things like the sun, people presupposing things like the sun and then making interpretations based on visible phenomena. And a lot of relevance is placed on these things when physics is being ignored. So, the question that I'm going to ask, and I'll ask Jeranism when he comes, and I suggest that everybody out there asks the same question. Can your model exist without physical downwards acceleration? The answer to that question is no. The globe Earth and stationary flat Earth both requires a physical downwards acceleration, which in reality does not exist. So this is where I get an issue when people have a focus, misdirected focus on the wrong things. The root of the globe Earth model, it's a requirement. Without a physical downwards acceleration, the globe Earth model is dead and done right from the off. Now, if you're a flat earther, if you're somebody who's looking to expose that model, then that's your silver bullet. The fact of the matter is that we have a vector in reality. Now, that vector you can test for yourself, and it's demonstrably up the way towards your feet. Demonstrable, repeatable by every single person alive. I'll just wait for people to return so that I can have the discussion.
I'm back. I'm back. I just got back. I'm here. We're waiting for Jeran to come back. I don't know if Rose is still here, but Rose, you can always chime in anytime that you feel you need to. Just fit in where you can fit in. But obviously, things got a little bit more serious with Dell's presence. But how you doing, Dell? You doing all right over there?
Yeah, I'm fine, mate.
So just to touch real quick, so the upwards motion of the Earth is, in my opinion, the biggest lie on Earth, because the globe Earth, not only does the globe Earth, but the stationary flat Earth now, which over 95% of flat Earthers believe, requires this downwards acceleration, this physical downwards acceleration, which doesn't exist. All tests, all practical demonstrations show that there is no physical downwards acceleration in free fall. It actually shows that it's a deceleration up. The displacement of matter shows that the Earth is pushing up, creating the density and buoyancy we experience here on Earth. Measurable, testable, repeatable. So again, if you could prove that objects don't accelerate down in free fall, by default, you debunk the globe Earth and the stationary flat Earth, because both of those models require this idea that there is this magical force pulling objects towards the ground. So that's why that's important.
Getting on okay.
All right, that's good.
just-
We're just having a conversation, and not that we all have to agree with everybody, but as long as we keep it civil, I think we could have an interesting conversation here.
Well, the thing for me, Natch, is people can have disagreements, but in regards to physics, for me, if we're going to apply reasoning and we're going to utilize things like physics, then everybody who's involved in the discussion, those that make claims are duty bound to demonstrate through practical physics and justify the reasoning that they're assuming, or the reasoning that they're standing upon. Now, as far as I've seen so far, none of these people can stand on any solid ground of reasoning in regards to their claims, especially with physical downwards acceleration. Electrostatics, people are saying in the chat, again, electrostatics is a factor in our reality, but it is not responsible for the vector that we experience. If people are going to claim that the gradient of pressure that we have, buoyancy and density that we have, people now are going to have to utilize electrostatics in order to demonstrate how that's possible. Now, so far, there's been absolutely nothing other than wishful thinking and sophistry being applied, the very same as the globe Earth, because the stationary Earth model and the globe Earth model are one and the same. They have both a commonality of physical downwards acceleration. They both require it. Now, again, anybody that's listening to this can go and test for themselves today that there is no physical downwards acceleration. So, people are talking about all the other manner of aspects of this topic, but ignoring this very fundamental, massive component, which bothers me.
Yep. Jeran, are you back with us? Okay, apparently not. I agree. I mean, when I looked into it, I questioned why there is no so-called.
I'm not gonna lie. When I originally watched this video, I actually thought Jeran wasn't gonna come back. I thought he was probably just gonna have some technical difficulties or something. So I give him props for coming back and actually having the discussion at the end of the day. So yeah, because I was again, I thought he wasn't gonna come back because he did take a while to come back. So
probably prepping for what's to come.
Maybe. So yeah.
Maybe they think that would actually come on.
Maybe, who knows?
Called buoyancy when things are at free fall, and why should it matter if gravity, so-called gravity, is there, and there is a kind of a downward vector rather than upward vector of things. Things are being pulled to the ground rather than the ground meeting up. Then it shouldn't matter. Like when you look at the slinky, like my assessment of that situation would be like they should all moving down while contracting together. But that's just the way I would look at it.
Well, it's actually wrong, Natch, because if you're a globe earther or a stationary earther, you've heard them both claiming that when I showed an accelerometer and saying there's no displacement from the accelerometer, that's showing that there's no acceleration, they all now say that that's because everything's accelerating at the same rate, which is a claim of a force and, the act of a force, which is totally preposterous to reality. Now, when we show the slinky and the ping pong ball in the jar dropping, that slinky is now elongated due to the buoyant effect of the ping pong ball. Now, according to these people, at that moment, everything now should accelerate towards the Earth at the same rate. But as we let that go, the spring inside contracts under its own tension. So there's another contradiction to that claim.
Yeah, I mean, me, I'm in agreement with that line of thinking. But again, being a retard of the flat Earth community, it might be incourteous, But really, all jokes aside, I do think these are very healthy conversations to be had with people who have varying beliefs. Because, if we are really honest with ourselves about, hey, what is this thing that we call gravity? What is this stuff we call celestial, phenomenon and such, and then let's put all the data together, and then let's really try to figure it out the best that we can, and I'm not an expert in any field, but I do question reality, and why people think the way they do.
I'm back. Sorry.
Yeah, go ahead. So, Jeran, if you don't mind, I'm going to give the floor to Del, and then you are welcome to respond. And I'm going to give it, give everybody the same opportunity, right? So, right now, I'm not making a hard amount of time that people are speaking, but I will start squeezing myself in if I feel like the conversation is becoming redundant, or people are repeating themselves.
Okay.
Go ahead, Del.
Jeran,
So Del.
can the globe Earth model exist without downwards acceleration?
Can the globe Earth model exist without downward acceleration? I wouldn't know how to answer that. I mean, they say there's no downward acceleration in free fall.
It's a simple question. Can it exist without a downward vector?
Oh, no.
Right. So if you test reality and establish that there is no downwards vector, then that's the end of the model. Correct?
Okay. Yep.
Yep. So I've heard a couple of times you stating some things, Jeran. And have you established whether there's a downwards vector?
Yeah, I think it's been shown.
Well, can you cite me something?
The work that they've done with the Venn diagram generator, that there's 100 volts per meter that goes up quite high in the sky.
I mean, electrostatics being in the atmosphere is not the question. I'm asking, have you demonstrated that there's a physical downwards acceleration?
No, I don't think that things in free fall accelerate.
So when I drop an object, does the object move towards the ground?
It does move towards the ground, yes.
So that's a claim of an acceleration, Jeranism.
So it's a what?
Again, real quick, they like to avoid the word acceleration, but the thing is that when something is at rest and you're holding, an object and you're holding it in your hand and it's at rest when you're holding it, if you release it and it starts to move, that's acceleration. From something that's motionless that starts to move, that's acceleration, regardless of the speed. So again, if something is at rest and then it starts to move, not only does it require a force, but that is acceleration. So again, they try to hide behind, words like fall and stuff like that because they don't have real definitions for these words, to describe the motion that they're talking about. So again, they try to avoid words like acceleration, like conceding that that's what's happening because that can easily be debunked. So that's what it looks like here. He's trying to avoid, conceding that objects accelerate in free fall because I think he knows that can easily be debunked.
Of course.
So.
That's a claim of an acceleration in a particular vector.
Yeah, I disagree. I think that we've been pigeonholed into that belief, but I believe there's something called momentum. I believe that anything falling has to be going faster in the second after it's the first second, and it has to be going faster in the third second than more than it was going in the second because it's gaining.
That's acceleration. So he's giving the definition of acceleration without claiming that it's acceleration.
Right.
So what the fuck, right? So
Speed.
Yes, so you believe and you claim that there's an acceleration towards the Earth?
If you're talking about increase in speed as acceleration, then yes. But if you're talking about F equals ma, that there has to be a force to accelerate, then I disagree.
Jeranism, let's take it simply. Is it your position? Are you still a flat earther?
Absolutely.
Great question.
not for long, right? We'll see.
They are stationary.
Absolutely.
So when I hold an object and I let it go, it's a stationary object now accelerating towards the ground.
It starts to fall because there's a downward vector, and then it's going to go faster in second 2 than it went in second 1 due to momentum.
Right, so your claim is that there's a downwards acceleration then?
Sure.
So why does no accelerometer detect that acceleration downwards?
Because you have to be outside of that frame of reference.
So I need to be outside of a car or a enclosed system that's moving in a particular direction to detect that it's in motion in a particular direction. Is that your claim?
No, because it's not in free fall and it's not going in the direction of the vector.
So
again, special pleading that this only happens in free fall, and any other experiment will obviously show otherwise. But again, in free fall, though, that's what's happening. Believe me. I don't have any practical demonstrations for it, but that's what's happening. That sounds like low birth rhetoric, if you ask me.
So what do you mean that it's not in free fall? What's the difference in this free fall Jeranism? Because if you're claiming that there's an acceleration downwards, you're now trying to nullify it by saying it's a free fall. So what's the difference? Because it's very simple. If it's a stationary,
real quick again, I know I've mentioned this before, but when somebody says that something is not accelerating down, but it's just falling, right? You gotta ask them in specific, what do you mean by falling? Because in my opinion, there's when it comes to motion, there's three different states of motion, I guess you can call it. The first will be acceleration, the second will be deceleration, and the third will be constant motion. So if something is in motion, these are the three categories that it would fall in.
Right.
It would be either accelerating, decelerating, or is in constant motion.
Right.
So when they are saying things are falling, what are you claiming? Are you claiming acceleration, deceleration, or constant motion? So obviously it's not deceleration because that's our position of the motion of the Earth. I don't think they're claiming constant motion because obviously if it's at rest and then and it starts to move, that's an acceleration. So it's not constant motion. So by default, it is an acceleration. Unless there's a fourth option,
Yeah, no.
then, that's the default position.
Direction of the vector.
I'm still speaking. Do you know what does a vector mean, Jeranism?
Change in direction? I don't know. Directional?
A vector is magnitude and direction, which means something's moving in a particular direction.
Correct.
Yes. So if I'm standing on a stationary Earth with a stationary object in my hand, how does it have a vector?
Because of the electrostatics in the world.
So the electrostatics are moving downwards towards the Earth.
They are setting the down direction, and then the relative density of the item decides where it displaces.
Mm-hmm. So how can I not detect that acceleration downwards?
How can you not detect? Are you talking about by the scientific world, F equals ma and all their rules and regulations?
A simple do you know what an accelerometer is?
Yes.
So why does an accelerometer not detect the downwards acceleration?
Because it's been preset that the phone is moving down at a certain direction.
No,
a certain speed.
Take a digital accelerometer is the only digital part of the accelerometer.
It's a very simple question. Why does an accelerometer detect acceleration in free fall? The real answer, the fact is because objects don't accelerate in free fall, But again, people that have a bias and people that have an agenda, again, I don't know what's going on here, are gonna go against the facts, even if it's right in their face. Where else do we see that kind of mentality with Globers? They have the evidence right in their face, but they're still going to go against it because they have a bias or an agenda. Regardless.
Well, either way, this is his livelihood. So
that's what happens too.
Partly part of the reason, I'm sure.
So
Accelerometer is the numbers on the screen. The mechanical parts inside work on displacement because when force is applied to matter, there is no force known to man that can accelerate all states of matter simultaneously without displacement. That's how an accelerometer works. So if I use an analog accelerometer, like a vessel with water and air in it, that tells me when a force is present because there's a displacement between the gas and the liquid. Now in free fall, there is no displacement of the gas and liquid, no acceleration detected. Why?
Because that's the direction that things go.
So is it your claim that gas... Is it
Down? What? Down, 1 second. I don't mean to...
Sorry, Nat.
Okay, go ahead.
Is it your claim then, Jeran, that you can accelerate gas, liquids, and solids without them displacing?
In the downward direction or in another direction?
Any direction.
Sure. No, you have to. If you move something in a direction that's not the downward vector, then you're going to get displacement.
So only in the downward vector you don't get displacement.
That is correct.
So that's the very same rhetoric as a globe Earth then, Jeranism. Yeah. They want us to believe that there's a downwards acceleration that's not detectable, and the claim is that you can accelerate gas, liquids, and solids without any displacement whatsoever. That's pseudoscience. That's a claim of fantasy. Can you qualify that claim by showing it in any other vector?
I just said that it only happens in one vector. You're like, would you just show it in another vector? No.
Right. So you understand that you're special pleading.
How?
Because you're making a claim that's not demonstrable.
How's it not demonstrable? If we know that there is 100 volts per meter going up, we can change the polarity in a Van de Graaff generator, making the polarity flip, making things that are very, very light, like iron filings or whatever, go the opposite direction.
Yeah. So you're claiming that electrostatics can accelerate gas, liquids, and solids without displacement. That's your claim.
No, my claim is that the electrostatic sets the downward vector, and then if something has no weight, no density at all, it would just sit there. So it needs to have some density, at which point it displaces and goes in the direction of the downward vector.
But gas, liquids, and solids are different densities, and your claim is that they all move downwards at the same rate?
No, not gas. Gas is different.
But if I release Jeranism, I don't know if you're aware of the tests that we've done. So if I have a vessel with water in it, and I'm letting helium bubbles into the water from the bottom, and the helium bubble is now rising through that water, the instant that I let that go, the helium bubble freezes relative to the water, and now the whole system, according to you and according to the globe, is now moving down, including the helium.
Right. It loses its relative density difference, right? Because
I thought you just said that apart from helium or apart from air.
What?
You just said a minute ago, except from air. No, I've just given you an example where the air and the helium does stay relative in the system, and your claim and the Globe Earth claim is that the whole system, the gas, the helium, the water, the solid, are all accelerating at the same time.
No, Globe has a belief in gas, and we have a different belief.
So what's your belief about gas?
That gas expands in all directions.
Right, and do we have a gradient of gas on the Earth?
There's a gradient, yes.
What causes the gradient?
It could be pressure, or it could be it does have something to do with the density of the gas. It does have, like, some gases are a little bit heavier than other gases, so they're going to generally be lower than the other gas. But there's also a constant mixing of atmospheric gases, so you wouldn't expect to see a perfect layering of gas.
But there's a pressure gradient.
Yep.
So how do you create a pressure gradient?
Usually, it has to be in a container.
Yeah, but how can I take our gradient, I can take our orientation, Jeranism, I can take buoyancy and density, and I can invert it and change it in any direction. That's.
I want to share a video demonstration because I think it's relevant, especially with the topic that they're going over right now in specific. So let me see. I'm already screen sharing, so hopefully this video plays. Actually, minimize that. Yeah. Okay, no. Let's see if it's not playing on the.
It's a little delayed.
Okay. I don't think it's gonna be playing in
Yeah,
the
I
live.
think it's showing.
Okay, let me stop sharing. And let me share this video real quick. Should have had it more prepared, but we could share this one real quick.
Could have sworn you had it set up there.
Right, no, yeah. All right, I'm gonna share this video because I think it's relevant with the conversation right now. In this video, I'll be doing two different density and buoyancy experiments. I'll be recreating density and buoyancy in three different vectors utilizing motion of a contained reference frame. In the first experiment, I'll be using a container with water, a red ping pong ball, and a steel ball. The ping pong ball and the steel ball will always displace relative to the direction of the force that's applied. For example, when I accelerate a container to the right, the container pushes the water in the same direction, creating a pressure gradient. The water is then able to push anything that's less dense, like the ping pong ball, in that same direction. That is what we would call buoyancy. However, the water is not dense enough to push the steel ball like the ping pong ball, so the steel ball remains in the same position. The steel ball only appears to move in the opposite direction of the buoyant force because the camera is also moving with the container. The ping pong ball has true motion and the steel ball has apparent motion. So the steel ball in this case, people could say, oh, well, the steel ball, there was a force that swung the steel ball towards the back wall of the container. But we know, that that's not the case. We know that it's the wall of the container that moved towards the steel ball, But again, visually, people could say that, oh, look, the steel ball looks like it swung towards the wall, just like the ping pong ball did. But in reality, only the ping pong ball moved towards the wall of the container, and the ping pong ball, and the steel ball didn't. It was, because both walls can come towards, of course, the objects, and both objects can go towards the walls. That's simple. The same principles apply when I accelerate in any other direction. In the second experiment, I'll be using a tube with water, an air bubble, and a steel ball. To accelerate the container down, I will be using a resistance band. As you can see, when connected to the earth, we can experience a force creating density and buoyancy. The air bubble is being pushed up, and the steel ball appears to move down in the opposite direction of the buoyant force. By the way, this first drop is free fall for anybody that may be confused. I was just showing how I was going to accelerate it for the rest of the acceleration drops, but this first one is free fall. You can also see the air bubble is flattened where the force is being applied. However, when I release the container into free fall, density and buoyancy completely vanish. The air bubble is no longer being pushed up and turns into a sphere, showing that there isn't a force present in free fall. I wanted to address this too, because somebody did bring it up, and I was going to address it as well. I might as well address it now real quick. The steel ball appears to still move down relative to the container because it's actually decelerating at a faster rate to the container. Why? Because it actually started to go into free fall before I released the container into free fall. So that's why the steel ball has a faster deceleration rate by the time I released the container. Again, because it was already in free fall before I released the container. So that's why there's still that slight displacement of the steel ball. It's still slower because, again, the displacement is showing that the container is moving up. Because density, obviously, the objects that move, the dense objects that move in the opposite direction of buoyancy, again, shows you the direction of the force as well. Buoyancy moving in the direction of the force and the dense objects moving in the opposite direction. So if the steel ball is moving down, then that shows you that the container is still moving up. Again, if you're claiming downwards acceleration, not only is the steel ball moving in the wrong direction, but the buoyant force of the air bubble completely vanished, and it turns into a sphere because it's not being pushed from either direction, up or down. So the air bubble is clearly showing that there is no force present. And it's literally a deceleration that we're witnessing with the steel ball. And
that's
the
a
upward,
great visual of that.
Yeah, and the upwards trajectory, by the way. So.
Yeah, there was confusion.
When I actually accelerate the container, so these are going to be acceleration now. Down, we can see density and buoyancy invert. The air bubble is being pushed down, and the steel ball appears to move up. Not only does acceleration require a force, acceleration will always cause displacement of solids, liquids, and gas, proving that objects don't accelerate down in free fall. Again, right here on the left, you can see the actual acceleration. Again, the steel ball appears to move down, showing that the motion is up. But when you actually accelerate it, density and buoyancy invert. So the air bubble starts to move down towards the direction of the force now, and the steel ball appears to move up. Again, this is the displacement we're talking about. This is what an accelerometer would be. Different states of matter contained, and then you accelerate a container.
Yeah.
The displacement will always be there when there is a force, when there is acceleration. In free fall, however, we don't get that displacement. Again, we just see the deceleration of the steel ball in the upwards trajectory and buoyancy completely vanishing. by the air bubble turning into a sphere and not moving up or down. So
It's good that you touched on that too, because there's a lot of confusion about why we're using demonstrations with contained water.
Yeah, because again, these are basically acceleration detection devices, I guess. Accelerometers.
Practical.
So there you go. I'm going to stop sharing and then go back to the other video. Here we go. Okay. To this one. Okay.
Yeah, I heard you talking earlier about the science, right? Now I'm talking about physics. I'm talking about changing all variables. I'm talking about changing the vector to any vector you want, and I can recreate the conditions of our reality. Can you do that with electrostatics?
I guess that's the way the world works, but I'm wondering what you mean by that. So you're saying you can take that gas that you just talked about, the helium bubbles rising to the top, and you can move something to the right, and you can cause the helium bubbles to go to the left?
Again, what he's saying is we literally just showed it. We recreated buoyancy and density and buoyancy to the left, to the right, and down. So yeah, we have demonstrated this.
I can cause the helium, but the air moves the direction the force is going in. So I can, if I've got a vessel standing here and there's an air bubble rising and a lead weight sinking, if I now accelerate that system downwards, the air bubble now moves towards the ground and the lead weight towards the sky.
Right, you've eliminated their ability to move.
No.
You've basically erased the downward vector.
Yes.
Right, so then it sits in the middle of the water.
No, that's in free fall. I'm talking about actual downwards acceleration and what happens in physical downwards acceleration. When we physically accelerate downwards, we get an inversion of the pressure gradient and the body.
Duke, Dojo, and Can, they're just literally just trolling the comments at this point. They literally have nothing practical. They literally are just asking dumb questions that have been addressed before. They're sea lining. They're not being honest. So yeah, I would say that they're trolling based on their behavior.
The buoyancy and density gradient. So it flips 180.
At what?
It flips 180 degrees.
At flips, or are you saying it flux?
It flips.
Flops. Yeah, flips. Flops, flips.
Yeah, I don't know. I'd have to think about what you're talking about. I don't really get what you're saying. I guess.
So, can I just paint a picture? Go ahead, Del. I don't mean to interrupt.
Jeranism, there's nothing about the conditions of our reality that we can't demonstrate in any other vector. So if we're talking about science and we're talking about hypotheses and changing variables, then I'm standing on solid ground. So far,
how are you changing the direction of the vector to the right or left?
By using motion.
What do you mean? It's already been set. How are you changing the electrostatics of the world?
No, Jeranism, we're talking about changing variables. So again, I'm going to ask you.
One of the major variables is the electrostatic force that goes down, and you just said you could just move it in another direction. So go ahead and prove that. No, you said you're scientific. Prove that. Then. Show me that you can change the vector to go to the right.
Yes, I've already done it. That's not my problem. You're just incredulous to what I've already shown. So I'm going to put it back to you, Jeranism. It's your responsibility, son, to change the vector using electrostatics because you can't. You're making a claim of something that you cannot isolate and change in any way, shape, or form.
I didn't claim to be able to change it. You did.
But that's part of science, Jeranism. You have to be able to manipulate and change the variables.
Yeah, and sometimes you can't. How are you going to change the variable of the direction of the electrostatics?
That's not my problem. That's your problem.
Okay. Well, it can't be done.
That's because it's nonsense.
So if there is an actual 100 volts per meter electrostatic force that's going from the top down, you're saying because we can't flip that and make it go to the right, that we can't talk about it or something?
That's because you're utilizing that in regards to our vector and the conditions that we have, Jeranism. You're attaching it to a downwards vector with buoyancy and density and these sorts of things. Now, if that's what you're claiming and you're claiming it can create these things, then demonstrate it in some other vector.
It can create what things?
Buoyancy and density, pressure gradients.
I don't think we need to change its direction to prove it.
Listen, see in physics, if I make a claim that something does something, I have to be able to manipulate that.
So what happens if you can't?
It's nonsense.
What do you mean it's nonsense? So change the direction. Change the direction of the sun. If you think the
I
sun
can just
is,
make any
hold on a
claim.
second. If I say the sun's going one direction, you're saying I have to be able to flip it in order to say that.
No, if you're going to make claims about the physicality of the sun, then you're going to be duty bound to demonstrate that.
Well, yeah, but you'll never be able to flip the sun. It's never going to go the opposite direction.
But
So
we're not
therefore,
talking
we
about
can't say anything about the sun.
We're not talking about flipping the sun.
Again, he's talking about the sun, something that's just optical, and trying to use that as an example to dismiss the physical.
Mhm.
Because I can't do this with the sun, that means the sun doesn't exist. So he's trying to use that same logic to prove his claim of acceleration. To say that, just because I can't show it, it doesn't mean it doesn't exist, type of thing. Again, it's very flawed logic, for sure.
In the sun, we're talking about.
There's some things in the world that are the way that they are, like hot goes to cold. We don't have to flip it and show that we can move cold to hot. It's just a natural law. It's just the way life works.
Is it?
Yeah, that's how life works. Just like pressure goes to non-pressure. You're basically saying unless we can flip it, we can't make determinations on the things that they are.
Jeranism, you're conflating two totally different things. You're talking about intangible phenomena, that being the sun, right?
Again, the false equivalence. He's trying to use the intangible sun, the visible sun, to try and disprove the physical, aspects of reality that show that there's no acceleration in free fall. He's trying to use something optical to debunk something physical. Like, come on.
I'm talking about physics. We're talking about motion. So
Okay.
right? So when I drop a vessel and buoyancy and density ceases in free fall, what happened?
You are going in the direction of the vector. Therefore, there's no longer a vector. There's no longer a reason for anything to displace.
So it's all accelerating in a particular direction simultaneously.
The bottle, the ping pong ball, the spring. Yes, everything's going in the same direction simultaneously.
Let me just read something out here quick, right? Anybody can go and check this. Special pleading. The allegation of special or new matter to offset the effect of matter pleaded by the opposite side and admitted as distinguished from a direct denial of matter pleaded. Misleading argument that presents one point or phase as if it covered the entire question and issue. Let's get another example of special pleading. Special pleading is an informal fallacy wherein one cites something as an exception to general or universal principle without justifying the special exception. Now, in this case, Jeranism's special exception, just like the globe Earth, is that there's a magical physical downwards acceleration that's not detectable.
No. Read the definition again. Read the definition one more time.
Special pleading is an informal fallacy wherein one cites something as an exception to general or universal principle without justifying the special exception.
Okay, I didn't do that.
Yes, you did. You said
there's no exception to general or universal rules. I'm talking about the general and universal rule. There's no exception to it.
So let me highlight where the exception is. We do not have access to any force where we can demonstrate the acceleration of gas, liquids, and solids simultaneously without a displacement occurring. Now, only on the downwards vector, you're pleading that that's the case, which you've done so a number of times already.
Because it's the general or universal way of the world. What did you say? Read the definition again.
I'm not talking about opinions, Jeranism. I'm talking about in physics.
Well, I'm asking for a definition right now. Because I don't want your...
Like, he literally sounds like a globe earther when you ask him for proof for gravity.
Now he's just nitpicking the definition.
Like literally just sounds like a glober. Like again, I'm not trying to talk shit or anything, I'm just being honest,
I mean, safe to say nobody at this point thinks he's in good faith, right?
Yeah. Let's be real.
Your opinion, I want you to read the definition again.
No, I'm giving you.
You don't want to read it because you realize that in the definition is the answer, and you're just going to pretend like it's not.
What's being clearly obvious here is
why don't you read the definition again?
That's
Why don't you read the
that's
definition again?
one of the most
Why don't
disingenuous.
you read the
people yet.
definition again?
One
Why don't
second,
you read
one
the
second.
definition?
Everybody mute up. Everybody mute up. I'm going to step in
Wordings.
right here. Okay, Dell, can you read the definition again? And then let's just go one by one, please, if we can. Okay, and then if you have a problem with the definitions, Jeran, then point it out after Dell is done reading. Thank you. Go ahead, Dell.
Special
Can
pleading
you
is
read
an
the
informal
definition
fallacy.
one more time?
Special pleading is an informal fallacy wherein one cites something as an exception to general or universal principle without justifying the special exception. Right. So a universal principle is an accelerometer, where an accelerometer detects the presence of force. It detects
Universal principle is an accelerometer, a man-made device, is now a universal principle.
it's force. It's how force acts on matter.
Just to be clear, a water bottle that has air and water, again, the container may be man-made, but the contents inside the bottle, which will be the air and water, show you the direction of the force and when there's a force being applied.
Mm-hmm.
So again, you can say that a simple accelerometer is man-made. Well, in reality, it's not. Again, the container may be, but the contents inside that show you the force and the direction of the force are not. Air and water are natural. They're
Doesn't get more practical than that.
Exactly. So again, he's trying to handwave this practicality, the simplicity of this topic by trying to say, oh, it's just man-made, so we can't trust it. But yeah, he talks about interferometry. Like, what the fuck? Like, it's fucking crazy.
And there's a lot of people in the comments that, again, complain about what's because the water is being contained and all this other. So, I mean,
like, I don't know what the fuck they're talking about. We're showing that that's an accelerometer and it doesn't show any displacement or any acceleration, in other words, in free fall. So when people start to say, well, the water needs to be not contained. What happens when the water is not contained?
it's
Like,
nitpicking.
what the fuck are you talking about?
They're literally saying they have a bias without having to say they have a bias.
Exactly. I mean, it's
They're
just
nitpicking.
too obvious. Like,
It's a universal principle. Yes.
The universal principle is that hot goes to cold, low pressure to no pressure, and things go down because that's the direction of the vector. That's all universal principles.
and things go down because unicorn farts. That's just the universe. That's just the principles of the universe. Like,
I'd argue the unicorn farts go up.
right? It's a gas, right? So, but they're magical. That's why. So you do whatever you want.
I know, Jeran, but you keep saying the vector. You don't
Yeah. No, obviously.
comprehend a vector's magnitude with
I
direction.
don't give a fuck about words. I know what I'm talking about.
Oh, so now you don't care about words. So now you're just being arguing.
downward
Up
direction.
against a wall. You're
Downward
disingenuous liar.
Direction. The downward direction. If vector's the wrong word, then you know what I'm talking about.
No, I don't, because you say words don't matter. So
No,
listen,
I said,
Jeran,
if you have a problem with vector, then what is the downward direction? That is the direction of free fall.
there's no detection of a downwards acceleration. Nobody can detect downwards acceleration.
Okay, can I step in? Can I step in real quick?
Wait, so hold on. I'm going to ask you a real quick question. Are you talking about if we drop a car from the Empire State Building, it's going to stay at the same speed all the way down?
What do you mean stay at the same speed?
Stay at the same speed.
But there's a change in velocity.
Okay, so is that
Again, he's trying to assume that objects already accelerate in free fall, and he's trying to justify it by the change in velocity in free fall between a free falling object and the Earth. Again, the change in velocity between a free falling object and the Earth can either be an acceleration of the object or a deceleration from the constant. So again, by him saying like, "Oh, well, are you denying that a car in free fall doesn't accelerate down?" It's like he's already assuming that it accelerates, and that change of rate is his proof. Which again, a change of rate doesn't prove either or. Physics proves, what's actually moving towards what, whether the free falling object is moving towards the ground or the ground moving up towards the object. Again, the change in velocity is not what's in question. The force or the acceleration of an object to the other is that's what's in question. What's moving towards what? Oh shit.
Stop the screen.
There we go.
is that not a acceleration?
Yes, it's a change in velocity is an acceleration, but the claims
You just said we cannot show acceleration.
Listen, Jeranism, an acceleration is a change in velocity. right?
Okay.
So see if I'm moving up the way, right, at 10 miles per hour, and then I slow down to 5 miles per hour. That's an acceleration. I'm still going in the same direction.
Okay.
Right.
So you just said, repeat what you said.
Again, acceleration is simply a change in velocity. So you could be decelerating from the constant or accelerating. Either or, you can say there's an acceleration. Again, being a change in velocity by definition.
Said one more time that we can't show a downward acceleration.
You can visually interpret the downwards acceleration. However, physically, you cannot detect that that's what's happening, because the detectors do not detect the downwards acceleration that's claimed to be there.
But the item does go faster as it falls.
No, it just appears to you like that. See if you were on a train side by side another train, Jeranism, right? And both trains were doing 100 miles per hour, and then the train to the side of you slowed down. It looks to you visually like that one went backwards.
Okay.
Right? So visually, you can interpret things visually, just like you can interpret train tracks are converging in the distance visually, but you know physically that they're not, because you measure them.
But you're on the train. What if you're outside the train? You would know which one is slowing down and which one's not, right?
You're changing reference, But the two train scenarios, just like you within the reference frame. So when you hold an object and you drop it, you interpret that goes physically downwards.
Correct.
Right, visually. However, if you now attach an accelerometer to that, which detects a force present in which direction the force is going in, it will not display for you that the force went downwards.
Right. Is an accelerometer man-made?
Well, it doesn't matter how you make it.
No, it doesn't matter.
No, because look, Jeranism, when a force is applied, you cannot accelerate. Can you accelerate gas, liquids, and solids without them displacing?
Can you accelerate? Yes, as long as it's in the direction of down.
Can you do it in any other direction?
No, because you can't erase the downward vector.
Right, so you
can't.
I
don't want to use that word anymore. You can't erase the downward direction.
Let's take it step by step. The reason why you can't do it in any other direction, why can you not do it in any other direction?
Because it's a general or universal principle.
What is?
Downward, down.
Yeah, we know that the assumption of down's there.
What?
Yeah, there's an assumption that there's a physical direction of down.
Right, because there always would be, right? No matter which direction it was, we would be living.
We're trying to establish if that's actually the case.
That there's only one down direction?
No, that there is a physical downwards acceleration. So the upshot is you claim there's a physical downwards acceleration, but we can't detect it, correct?
No, I don't claim that. I don't know what you're talking about. You stop saying what I claim.
Like, so is there a physical downwards acceleration?
If you're talking about acceleration being a change in velocity, then things that are dropped in the downward direction get faster because of momentum and they change velocity, so therefore they're accelerating.
So you're claiming there's a downwards acceleration?
Yes.
How do we detect it?
Measuring distance over time.
And how's that going to tell us that there's a magnitude and a direction of something physically moving in a particular direction?
Again, just like a globe earther, his proof of physical downwards acceleration is not physical, it's optical. So he's saying that visually there's a change in velocity. And again, that's his proof, no different than a globe earther of a physical downwards acceleration, which it clearly is not, So I don't know how he's going to justify that belief. Again, Dell keeps asking him, but I think what he does go to is the interferometry thing, that he mentioned in the beginning, but we'll see.
Because if you drop a car off the Empire State Building and measure how far it falls in the first 20 floors, and then the next 20 floors, and then the next 20 floors, it's going to be going faster on the last 20 floors than it did on the first.
But if I attach an accelerometer to the car, it detects no acceleration.
Exactly.
Okay, what is the accelerometer made of? Is it a man-made item?
Jeranism, listen, it's
simple. When I ask you questions, you just blow air and you just want to move the direction. You're not answering.
Okay.
You're not getting it.
There's two things. Either you're really, really ignorant, or you're just plain dumb. And if you're really ignorant, if you're really ignorant, I suggest that you learn. Right? Because I'm trying to educate you, and you just don't seem to want it. You seem to be fighting for the sake of fighting.
Well, you seem to be fighting for the sake of fighting. You have all the truth. You're the arbiter of truth. You're the physics expert. We should all just bow to you and listen to your explanation of downward directions.
Again, you're just talking shit now, you know?
Your explanations, no, the demonstrations.
Again, he's trying to make it seem that these demonstrations are so complicated and you need to be some kind of physics wizard and professor to be able to understand them and preach them. And the fact is, a 10-year-old can't understand these
And I
experiments.
think that's like the aim, to make it seem like the average person wouldn't be able to get it.
Well, just look at all the comments right now. All
Well,
these
yeah.
trolls in the comments are
I want to get
literally,
it, but
you know,
I'm trying to understand, but
you know, and then like
observations.
exactly.
And, just their bias. And I don't believe, I don't think. And it's like, and when it comes to physics, there's no space for your belief or your thinking. I mean, it's not really opinion based. You have to be able to demonstrate your claims or they're no.
Exactly. Yeah. Again, just trolling the comments, you know, asking stupid questions with no practical demonstrations. Really.
No, but
Sea lining.
I can demonstrate how an accelerometer works.
How? I asked you what it was and you couldn't tell me.
Because when force is right, Jeranism, can you provide me a force that can accelerate gas, liquids, and solids without them displacing?
How many times are you going to repeat the same thing?
Because you're going round in circles, ignoring it.
Didn't I answer it? Did I not answer you already?
Only in a downwards vector, right? So you're special pleading for special circumstances.
Sorry, that's a general or universal principle. Again, you're not getting it.
It's a general or universal principle that the Earth's a globe vibrating and gyrating through infinite
Who said
space.
that? Who said
Well, that's
that?
a general principle, is it not?
Not according to me.
Well, not according to me. And when you're just saying then, Jeranism, so see how disingenuous you are.
How am I disingenuous? You said that I'm going for special pleading. Whatever the hell that is. Okay, well, I'm not, because you said it's an exception to a general or universal principle.
Well, can it be demonstrated in any other direction?
No, nobody's
Right,
claiming
so it's
it.
special then.
No, it's not. It's a general or universal principle.
It's a general or universal principle that the Earth's a globe in outer space.
Okay.
Right, so what's your point?
What's your point? You brought it up, not me.
You're the one that's saying general principles and stuff. But
That's in your definition, dipshit. That's your definition.
Listen.
All right,
I don't give a fuck about
I need to
definition.
step in a little bit. I need to step in a little bit.
Genius cretin you are, son.
Yeah, I'm sure. Yeah.
Okay. Okay.
It's obvious
So
for
the
everybody,
first,
son.
One second, Del.
Right,
One
go for
second, Jeran, please.
Yes.
So the first thing to do is again, I think we have to get back to the point of accelerometer. Now, let me ask both of you guys a question. Del and Jeran, do accelerometers exist? Yes or no?
The man-made item, yes.
Yes, they exist.
Okay. So when you say man-made item, Jeran, is there a different accelerometer that we need to discuss, or is there an accelerometer that we can all agree on? That's the first thing to discuss.
There's lots of different kinds of accelerometers.
Right.
Okay. So what are 1 second, Del? 1 second, Del, please. So if there are different.
There could be different kinds of accelerometers, like the different states of matter within them, but the principles of an accelerometer that relies on displacement are all the same. So again, the principles of an accelerometer, whether digital or analog, are exactly the same in all. Again, they rely on displacement to show you when there is a force present. Not only that, but the direction of the force as well. Again, due to the displacement of the accelerometer. Again, there could be different states of matter that make up the accelerometer, like different materials. But again, the principles of the displacement of the accelerometer are all the same. Mm-hmm. And that's why, air and water in a container it will be a analog or a simple accelerometer, because again, you will always get the displacement of those two different states of matter, gas and liquids, when you accelerate the bottle. So again, they all rely on the same principles.
Are different types of accelerometers? Can you just tell us what they are and how they differ?
I'm sure there's electrical ones. I'm sure there's pressure ones. I'm sure there's magnetic ones. I'm sure there's tons of ones.
Okay. Yeah. So there are different, mechanisms of an accelerometer.
There's not?
No.
What do you mean?
Okay, why not? Why not? 1 second, Jeran. Why not, Del? Why is it not true? Go ahead.
Because an accelerometer works on the fact that when force is applied, you cannot, unless two different states of matter or two different bodies are rigidly connected, when force is applied to one, there'll be a displacement because force is not multifaceted. There is no force known to man that can apply itself to various states of matter simultaneously in order to apply varying amounts of force in order to accelerate different states of matter simultaneously. It's nonsense. The reason an accelerometer works is because you can only apply force to one aspect and the other one, due to inertia, will remain in its position and we will get a displacement. That's how an accelerometer works. They all work on the same fact.
Okay. Stop there. Jeran, did you understand it? And do you agree or disagree with that? What Del just
No,
said?
I don't think there's a reason I have to agree with a man-made device that he's claiming can or can't do something.
Is wind a man-made device?
Is what?
Is wind a man-made device?
One what?
Is wind?
Wind.
Oh. No.
Right. So if we've got natural things in nature like wind and it blows on something, right, two different pieces of matter, then the two pieces of matter displace relative to each other as the wind applies force to them. So that's how we comprehend accelerometers. That's how we devise them, because we comprehend that force cannot act simultaneously on all states of matter simultaneously.
Again, let me go here. Again, what you're claiming if the Earth is stationary or the objects can accelerate without displacement is that you basically are saying you can accelerate this container right now that has water, a ping pong ball and a steel ball, a gas, a solid, a liquid, and a gas. What you're claiming is that you can accelerate this without the steel ball and ping pong ball displacing. In other words, you will have to be able to accelerate it and the ping pong ball and steel ball remain in this same position that they're in right now.
Exactly.
So imagine accelerating and they remain like this. That's the kind of acceleration that globe earthers and stationary flat earthers are claiming now. The reality is that when you accelerate, you always get this displacement. This displacement here. Again, you can see instantly as soon as this is slow motion. The instant I start to move the container in a particular direction, we get that displacement 100% of the time. You cannot accelerate a container without displacement. And that's exactly what globe earthers and stationary flat earthers are special pleading for in free fall. Again, reality shows you that there's always going to be displacement of solids, liquids, and gas when contained. And again, if you're claiming acceleration, So just wanted to make that point.
So it's taken from the natural world. That's how they work.
I'm assuming that's how everything works. Okay. So we take accelerometers from the world that we see, and then we measure whether or not something's moving. Correct?
Mm-hmm. Yep.
Okay.
And the reason we know is because when force, do you understand the word force? Jerry, I don't mean to
Are
be
you talking about the scientific word force?
Just what's force to you?
Okay. Action.
Right, and force is something external to something else acting upon it.
Oh, could it be something inherent in it? I mean, there's nothing external to me that's causing me to push something. It's me doing it.
Well, that's your will.
Yeah, but you are the external force.
Will and volition are a whole other, discussion. But obviously, you comprehend that there's a life force in you that gives you the ability to move.
Correct. Okay.
Right. But when we're talking about inanimate matter requires something external to it in order to make it move. Correct?
Okay.
Do you agree?
Well, again, if you're talking about a rock dropped from the top of an Empire State Building, I don't think it necessarily needs any force causing it to accelerate because it's going to get faster in second 2 than it was in second 1.
Hey, but hang on. So inanimate matter, it's just as simple. Can inanimate matter move by its own volition, or does it require an external?
Okay, I want to address this comment by Dojo. When two magnets lead together, the force is electromagnetic in nature. No motion is required for the magnets to meet. So what you're saying is that there isn't a flow, you know, of electrostatic field that creates this attraction or this.
How are the magnets coming together?
Exactly. Are you saying it's magic between them, you know, that makes them come together? Of course, there's something causing that.
Mhm.
And that something only affects metal. So if you're claiming that this force can affect all states of matter simultaneously with, you know, without displacement, that's a claim that has no proof. You're just talking shit now. Again, you're saying that, oh, magnets can come together and I can't see what's happening. So that means all states of matter can accelerate simultaneously. That's the kind of logic you're using. Reality shows that that's impossible. You know, electromagnetism, you know, it only affects metal. It can only attract metal objects. You put up a piece of wood, what's going to happen? No motion.
Exactly.
You put a piece of plastic, no motion. Again, you put gas in front of it, nothing's going to happen. You know, you could put a ball of gas, a ping pong ball. So, you know.
You actually have to think these things through before just claiming what you've heard other people say.
Exactly. Again, just regurgitating, you know, bullshit and thinking that they're going somewhere with it. Like, it's retarded. All right.
No thing.
Okay,
Acting
it
upon it.
requires an external force to push it off the edge or whatever.
Now, when I stand on top of the Empire State Building holding a rock on a stationary Earth, which means that the Earth's stationary, I am stationary, the rock is stationary. Now I remove my hand from the rock. It's your claim that the rock now accelerates.
It's my claim that it goes in the downward direction because of its disequilibrium with its.
So from from stationary to moving as an acceleration, correct?
Okay, yeah, according to you, yes.
Yeah. So that means there's an external force acting.
Not according to Jeran. Let me just step in. What Jeran is saying, and you can disagree with this, is that there is no force applied to the rock that is falling. It's just falling because of buoyancy, basically. Am I understanding you correctly? That there is no force?
I believe that
on the rock? Okay.
misapplied momentum. Yeah.
Right, but momentum,
Okay, so
momentum is something that's already in motion. On a stationary Earth, standing on a stationary building, me being stationary with a stationary rock, there is no.
Again, just like the word fall, they're using this word momentum again. Okay, what do you mean by momentum? Is it accelerating, decelerating, or constant motion? Again, those are the only three options you have if you're talking about something that's in motion. Again, it's either accelerating, decelerating, or constant motion. Again, using words like fall, it's falling. It's not accelerating, it's falling. Or it's just, it's momentum. It's not accelerating, it's momentum. And it's like, what the fuck? Like, again, they're just hiding behind these words that don't have real definitions.
They never get specific.
You know, again, you have to ask them specifically, what do you mean from these three? Again, if there's a fourth, please share it, you know?
Yeah.
So again, just hiding behind language.
And demonstrate it. But
yeah, and actually demonstrate a claim as well, obviously. But they can't even get past the language part, you know, and it's fucking crazy, you know?
No momentum.
Okay, because it hasn't left your hand yet.
So once it leaves my hand, it must accelerate.
Right. Well, unless the air balances it out. But yes, for the most part, it's going to accelerate.
From stationary to moving as an acceleration, I don't know how that's difficult to comprehend.
That's fine. It's just, but you're talking about words and what we associate with them. It's not universal. It's not like God didn't place the word acceleration here, and then we have to follow this exact rule. It's just your.
That's fine. If you want to get hung up in the words, we don't need to get hung up in the words.
Okay, good.
It's simple to comprehend. If something's stationary and then it moves, that's an acceleration. It's not difficult.
I agree with you. We'll call it acceleration.
Yes. So we understand that acceleration of inanimate matter requires an external force.
Okay. Now, if let's say that item then started to fall at just a universal speed, or it just was falling at its terminal velocity, you're saying then that there is no acceleration?
No, because
but
I'm talking about terminal velocity now. He's jumping ahead, so he's skipping the acceleration part. Now, terminal velocity, there is no acceleration, right? Again, I don't know what he's trying to prove by saying that.
It's just a diversion.
Yeah, if anything, he's trying to divert from the main point, talking about terminal velocity now and how that's not acceleration. So that proves, I don't know what it proves again, but yeah.
Well, if it's stationary and I remove my hand, then it's by default that position now has to claim that that's moved from stationary to moving, which is an acceleration. An acceleration.
But it could be a 0.1111 second acceleration, and then it's done. You're saying that the acceleration just keeps going or something?
No.
Oh, okay,
No,
so
no.
I agree with you that it accelerates from the split nanosecond that you let it go. It's got that tiny bit of acceleration, and then that's it. The rest is momentum.
No, momentums can't provide acceleration. Momentum is a rate that it's going at.
That's what you believe. That's what you're.
No. Don't listen. Don't misrepresent. At no point have I claimed any of that, Jeranism.
You just claimed it right now. You just claimed it right now. I'm saying I think that when something is dropped, because it has to go faster in second 2 than it went in second 1. So therefore, momentum is making it go faster.
Okay, so he's basically claiming acceleration, but an acceleration is being caused by momentum. Am I hearing that correctly? So he's not claiming that acceleration is being caused by a force. He's claiming that acceleration is being caused by momentum. Wow. Acceleration is being caused by motion. Okay, but motion doesn't cause itself. You require an external force
What's causing
to cause the motion of the matter. The motion cannot create itself and then create acceleration. What the fuck? Is that what I'm hearing? What the fuck? Oh, man.
You're just assigning the word acceleration to that, and then making rules that acceleration has to follow.
Momentum
is that word then.
But momentum's not a force, Jeranism.
Oh, of course not. According to science, it's not.
Of course it's not. Force is what causes momentum.
Okay.
Momentum is our language to describe something, right? We're talking about forces and actual physicality.
Okay, so if you're on a big ramp, there's a huge ramp, and you're at the top of it with a car, and you just push it a tiny bit with your pinky.
Mm-hmm.
Give it a little tug. Okay, now from that point on, the car will accelerate down the ramp, correct?
Well, there's a change in velocity, yes.
Okay, so what is the force causing the speed to change?
The upward push of the Earth.
The what?
The Earth pushing upwards.
On a ramp?
Yes.
I asked, what is the reason the car gains speed? And you said because the Earth is moving upwards?
Listen, right, if you're on Earth, right, just listen to this, right? If we're in a reference frame that's moving, say, 1,000 miles per hour, right, uniformly. Now, to us within the reference frame, we're at rest and things appear stationary because everything's moving at the same rate. Okay? You understand?
Sure.
So when I now have a car on an inclined plane which is connected to the Earth, right, and I release the brake of that car now has the inertia of that car is present. There is nothing to push against the car because you've got it in an inclined plane. Now that car now starts to lose the speed that it had as the Earth continues to push up past it.
Yeah, I guess I don't get why would that cause the car to go faster?
What do you mean faster?
If you're on a ramp and you push a car down a ramp, it's going to be going faster in the second leg of the ramp than it went in the first leg.
Yeah, because there's a misunderstanding of.
Again, he's trying to compare a free falling object, how there's a change in velocity in free fall, to a car going downhill. Again, one is connected to the Earth and the other one is not. So the one connected to the Earth, well, the Earth's still making contact with it.
Mm-hmm.
So there's going to be, something that's measurable there. We're in contact with the Earth. Again, he's trying to, equate that to a free falling object. And because there's a change in velocity in both, and one of the car shows acceleration when connected to the Earth, then that means the free falling object is also accelerating, even though accelerometers don't detect that. Again, he's using a false equivalence, faulty logic, again, to try and justify his belief. Again, doesn't make any sense.
Of what I'm actually saying to you, Jeran,
it's not a matter of what you're saying to me. I'm asking you a question.
Because I'm trying to get you to comprehend. I gave you the example, right? If you and I are both on two platforms right now, moving upwards at 100 miles per hour, right? And your platform slows down to 50 miles per hour. To me, visually, it looked like you went downwards. But you didn't. You're still moving upwards at a slower rate now.
Mm-hmm.
So visually, I can interpret that you went down.
Sure, unless somebody from the outside was able to see it.
Yes, but none of us are outside of the Earth's reference frame.
Okay.
So I'm just trying to get you to comprehend visually how we can interpret things.
So isn't what you're just saying is just another explanation, and nobody would be able to know which one is true unless we were on the outside looking in?
No, because the accelerometer detects the upward push.
The accelerometer.
Yes.
So hold on, let's go back to the two platforms. We put an accelerometer on each platform. You're saying that we could read from the accelerometer and determine that one of the vehicles simply slowed down, or one of the platforms.
If I have, like, say we've got a vessel on each platform, Jeran, right? And my platform's doing 100 miles an hour. Now, in this vessel, we've got an air bubble that rises at a set rate, okay? Now, my platform, whatever speed my platform is moving at is going to be related to the speed that the air bubble rises through the medium.
Okay.
Right? Now, I can show you this. I can accelerate, the vessel and increase the rate of buoyancy, right? So that tells us the direction that a force is going in. If you've got an air bubble in a vessel and you accelerate it in any direction, the air bubble will move towards the direction that the force is going in, right? So when we set a simple bottle on the table and we see air bubbles rising, the air bubbles are showing us the direction the force is traveling in.
What?
Now, I can demonstrate that to you by changing the direction in any way you like.
Again, like in the experiment I showed, the ping pong ball has air. So when I accelerate the container in a particular direction, the ping pong ball moves in that direction again because it has air in it. It's less dense in the water. Then that will be a buoyant force, that the ping pong ball is experiencing, in the particular direction you accelerate. Very simple, very easy. So when Jeran says, what? Acting like he didn't understand that. I mean, if he's being honest, then his comprehension skills are very, very weak. But I don't think, in my opinion, Jeran is that dumb. So yeah, in my opinion, he's acting like he doesn't understand. But again, that's just my opinion. I can't prove that.
I mean, it appears most people are currently sea lion. So
yeah, a lot of commenters, a lot of content creators.
It seems like that's the only option or the default option they're all resorting to, since they can't demonstrate their claims, they can't do anything else. So it's just like, well, time to just sea lion.
Yeah, pretend like they don't get it and act like they're trying to get it.
It's just too complicated. I'm just the average Joe. How am I supposed to get it?
Right.
But it's pretty simple.
Yeah, exactly. I guess they're trying to overcomplicate something that's very simple, and that's exactly what we're seeing.
If I accelerate it downwards now, the air bubble now moves towards down. If I accelerate to the left, the air goes left. If I accelerate right, it goes right. If I accelerate left diagonal, it goes left diagonal.
Okay.
The separation of these things shows us the direction a force is going in. So now when I release that, as the air bubble's rising and I release it from free fall into free fall, so it's no longer connected to the earth, so the motion transfer is no longer felt, it's no longer present, the air bubble stops moving through the water because there's no compression there anymore. As soon as I now apply a force to that in any direction, immediately the air now starts to move through the water in that direction.
Mm-hmm. Yeah, and downward is different than every other direction.
And I can do it also with any other material. I can do it with a flame. If you've got a candle and a flame shape that's going upwards, if I now accelerate that candle downwards, guess what happens? The flame goes towards the direction of acceleration.
So then if you spin a flame on the outside of a rotating disc, well, the flame goes to the inside. So you're saying the acceleration is on the inside then for a spinning?
Well, that's centrifugal. Yeah, well, I was talking about linear motion, but if you want to talk about centrifugal, we can talk about that, but it's not related to what we're talking about right now.
No, but if you're going to use the flame in one example, then it would have to work in the centrifugal example, but actually a centrifuge pushes things to the outside, not the inside.
Does it?
Yep, that's how centrifuges work.
But a centrifuge is a pseudo force. It's not an actual force. The actual force is the actual rotation of the platform. The effect that we experience is a pseudo force. It's not an actual one.
So what makes something a pseudo force?
Well, an effect of force. So when you go on a roundabout, there's levers and mechanisms that cause that rotation. That's the force. The force that's there is the pressing of one lever against another lever.
Okay.
Now you have inertia, and a rotation is a constant change in direction, which you experience as a force, but it's not really.
Okay. So, I mean, does that apply at all to this idea of dropping things from buildings or being on platforms?
It's all related because it's mechanics and it's physics. You know, force is external to matter. All forces are pressure.
Here's my issue, though. It's just if you're going to bring up pseudo force now, in regards to, I'm just wondering, is there any pseudo forces when it comes to items dropping, things rising? There's no pseudo forces there. Everything's an actual force.
Well, of course, you know, as I say, when things are connected to the Earth, we have buoyancy and density. So there's a force present. As soon as we remove it from the Earth and put it in free fall, the air cannot push against it the same as the solid ground can. So we have a ceasing of buoyancy and density and pressure.
Correct. The same thing as why water in your glass sits in your glass, because it cannot accelerate down. It can't go down because there's a bottom of the glass there.
Yes, and when I accelerate the glass downwards, what happens?
Well, if you're accelerating it faster than the downward fall is, then you're going to get a displacement up.
So how can I accelerate faster than the downward fall? What rate's the downward fall?
According to them, an average of 9.8 meters per second.
So 9.8 meters per second is roughly about, you know...
To put it into perspective, 9.8 meters per second, it's roughly about 32 feet in 1 second. So when they're saying, if you accelerate faster than 32 feet per second, that's when you get the displacement. But we can accelerate something, vertically, horizontally, left or right, from 0 to, only like 4 feet in a second, 2 feet in a second, which is significantly less than the 32 feet per second in free fall, and we will get the displacement. Again, just this special pleating in free fall. If you accelerate faster than 9.8 meters per second, that's when you get the displacement. So anything at 9.8 meters per second or below that acceleration in free fall, it won't detect it. That's obviously special pleating there, because obviously we can recreate acceleration that's way less than that, and we will get the displacement. Again, special pleating. Again, when things fall in free fall, again, in 2 seconds, that's 87 miles an hour in 2 seconds. Just so people could get a perspective of what kind of acceleration we're talking about. That apparently doesn't have displacement, in free fall. 87 miles an hour in 2 seconds. Like, that's crazy acceleration, that's not detected. But believe me, it's there, crazy.
Or 28 meters in a second.
Yeah, I don't really know if I believe that necessarily. I've never done a test myself to prove it.
So if I apply an accelerometer to even 10 meters over a second, I get a massive display of acceleration. But
how much? Is it comparable to 9.8 or no?
Well, I'm shortening it. I'm giving it more leniency by shortening the distance. If I say, right, there's a 10 meter distance now, and in the space of 2 seconds, I want you to accelerate something over the space of 10 meters within 2 seconds, which is heavy lenient towards this claim, then you're going to see a massive display of acceleration within the accelerometer. But yet, we've got a claim of 9.8 meters per second from both globe and stationary flat earthers, with absolutely no detection of this downwards acceleration. I find that highly incredible.
Yeah, I would have to think about it. I mean, there is gravimeters that supposedly measure that. Now, I'm not making any claim on that. I've never used one, never seen one. But there's claimed use of gravimeters, which you can take around, that drop little items inside of them and supposedly come back to somewhere near 9.8 meters per second squared.
Yeah. There's other tests you can do, Jeranism. There's a few videos you can go and watch right now where somebody has...
So are you saying that there is or isn't 9.8 meters per second squared on the Earth?
Well, this is the thing, I don't claim there's a downwards acceleration, so it's different for me. If you go and look at these videos, you can get a guy that has a meter-long test tube with a liquid in it, right? And he drops a ball bearing into that liquid. Now he times the drop and he markers the beaker with lines, and the spacings are equidistant. There's no acceleration of the marble through the liquid.
Yeah, I think that's because of the atmosphere. That's because of the air, right? Air slows things down from falling.
No, it's a liquid. It's in a liquid.
Well,
So it doesn't. If you accelerate through a liquid, it doesn't matter. If you're claiming an acceleration through a liquid, an acceleration should still be witnessed. Now,
but not 9.8 meters per second.
Well, when he drops the ball bearing into the top of the meter-long test tube, he markers the test tube by increments all the way to the bottom and times it. There is no increase in speed or acceleration of the marble through that liquid.
Okay, but there's no claim that there is an acceleration in water.
But so water's not accelerating down. Nothing.
I don't know. What are you talking about? You're talking about a sitting body of water that has an ocean floor. Then no, it's not accelerating downward. It's stopped.
What's keeping it down?
It's density.
Density is not a cause of weight or direction.
Oh, here we go.
It's not though. Explain to me how.
Again, we just showed the experiments. Again, I'll show with free fall.
What does he mean? Oh, here we go. Like, oh, here comes some truth.
I'm going to show what free fall actually looks like. This is what free fall looks like. Again, buoyancy, the air bubble being pushed up when I'm holding it, that motion of the air bubble moving up completely vanishes. And not only that, it transforms into a sphere, showing that it's not being pushed up or down in free fall. Again, the steel ball shows that it's still that is displacing in an upwards trajectory. So relative to the bottle or the container in this one, it's all decelerating in the upwards trajectory, again, with buoyancy completely vanishing. So yeah, so density and buoyancy are not causes of themselves because they vanish in free fall.
Exactly.
They're effects of an external force, or in other words, acceleration.
How density is a cause of direction.
You said it's not a cause of weight.
Or weight. How is density a weight? What is weight?
Because I'm more dense than my sun, and so therefore I weigh more.
What is weight?
Weight is how much density we have pressed to the earth due to our density and due to the downward direction of the electromagnetic force.
So you need two factors then, right?
I don't know what factors you mean. It's
well,
weight.
weigh yourself in air. How are you going to do that?
In air?
Yes.
Go stand on a scale.
In air?
I don't know what you're saying. Air?
Look, I'm trying to get you to understand. You're saying weight. Listen, weight is not a property of matter.
No, it's because it's density or not medium dependent.
Yes, so you need two factors. You need something pressing against it. So if I put you into a centrifuge right now, Jeran, and you were pressed against the wall with a set weight, and I now accelerate that, your weight increases.
Correct.
Right. So weight is not relative. It's not a factor of matter.
No, it's a factor of matter based on its medium. And it's acceleration or it's non-acceleration, or if you're in a centrifuge or not, right? That all is going to make a difference.
Well, we agree that weight's not a property of matter.
Okay.
Right.
It's an attribute of it.
Yeah. So what causes the water to stay on the earth?
Density.
Density. What does density do? How does density tell things to go down?
Because it displaces, because it weighs more than the air it's in, and it has to go in some direction. The direction it goes is the one where the electrostatic force points down.
Right. So electrostatics can direct density.
It sets a downward direction.
Can you use electrostatics to set a different direction?
Yes, you can use the Van de Graaff generator to flip the polarity, and you can get things to rise instead of fall.
Can you use a Van de Graaff generator to change the direction of buoyancy and density?
I just said yes.
Can you cite me a video that shows that you can change?
Again, what Dell is asking, that was asking is a demonstration of electrostatics creating this effect here without motion of the container. So the container has to remain motionless, and you have to recreate this effect of density and buoyancy. In other words, the displacement of density moving in one direction, or appearing to move in one direction, and buoyancy in the opposite direction. So again, you have to recreate this effect, again, a solid, liquid, and a gas contained, and create a displacement without accelerating the container or moving it, in other words. So again, that's the kind of experiment you would have to recreate using electrostatics or whatever your claim is that causes density and buoyancy. So this is what we're talking about. Oh my God. There we go.
Change buoyancy and density using a Van de Graaff.
Sure. You mean show you a iron filing going from the ground to the ceiling?
No. You know, if I've got a vessel with water in it and an air bubble rising and a lead weight sinking, and the air bubble
you would need a massive change in the electrostatics. Massive.
So this
Again,
is
100 volts per meter. That means
Right.
every 3 feet, it's another 100 volts. How are we gonna generate the flip of that?
So you can't change it, right? That's fine. I accept that, right? That's the same as a globe Earth. Now, when I say to the globe Earth gravity, and I say show me gravity in some other form, they say they can't because they need a big enough planet. They need to escape the Earth and show us a different planetoid in order to demonstrate it. You're now saying the same thing.
Yeah, I don't know what to tell you. I mean, you can't change that direction. So
Right.
you're basically saying that when there's a universal law, something that God placed the way it is, that because we can't flip, what are you making noise for? Can you shut up for 3 seconds?
Because here we go to the God of the gaps. Now you'll just jump to an argument that that's just the way it is. No. That's not how it works here.
Okay, so why does hot go to cold?
Because of pressure.
Then why does pressure do that?
Temperature and pressure are both intricately related.
Okay, so what causes low pressure to go to high pressure, or high pressure to go to low pressure?
Because of the push of the Earth. The only reason we have that pressure is because of the motion. But listen, let's not jump. Let's get back to that point again, because it's hugely significant. And I hope that you're intellectually honest enough to own it, Jeranism. Just like the globe Earth, they cannot isolate and demonstrate what they claim, and you cannot do the same. You're now saying it's just the way it is. That's your excuse.
What are you asking me to demonstrate to you?
We spoke about electrostatics, right? And I asked you, can electrostatics all...
Again, what's being asked is you have to accelerate a container without displacement, and you also have to create displacement on a motionless container. Because those are the two claims that are being made here. The Earth is motionless, but somehow creating density and buoyancy. And then objects in free fall are accelerating without creating density and buoyancy. So again, two contrary claims to what reality shows. So you're going to need a practical demonstration of those two claims. I mean, how hard is that to understand? Like, it's pretty straightforward, you know.
alter the buoyancy and density gradient? You said yes. Then
yes,
you said
take an iron filing. Hold on, you can take an iron filing that on Earth will go to the ground. Great.
Yeah.
We can put it in a Van de Graaff generator, flip the polarity, and then the iron filing now goes up. So we just did exactly what you asked for.
I can use a magnet to levitate metal. Does that now mean that it's magnetism that's responsible?
If you're asking me to use magnetism, you asked me to use electrostatics. So we use a Van de Graaff generator. Make up your mind. What do you want me to show you it?
But it's your claim is electrostatics is responsible for the conditions of our reality. So that's why I'm talking about it.
So then I said, put it in a Van de Graaff generator.
Right. So can you use a Van de
Graaff
Graaff
magnetics?
Can you use a Van de Graaff generator or magnetism to invert buoyancy and density to change its direction?
I just said yes. With an iron filing, we can do it in a Van de Graaff generator. By flipping the polarity, it rises.
Again, he's talking about just one state, one object. In other words, kind of like getting a helium balloon, for example, and making it stick to a wall, or when you rub it. He's trying to use that. Which is, again, it's a parlor trick because it's not proving what we're talking about. Again, solids, liquids, and gas, contained and displacing when a motionless container. Again, we're not talking about just one object, getting stuck, to the ceiling or whatever.
So you can take an accelerometer and use a Van de Graaff machine in order to change the accelerometer's direction.
What do you mean change? No, an accelerometer has weight. It weighs a lot. What is with all the noises you're making? It's like.
I'm not making noise.
You can act like a petulant wee child all you like, son. You're just exposing yourself even more. Which
I'm exposing myself because you can't shut up when you ask me a question. And everything I say, you answer with. That's you, not me.
That's fine. Because I'm disgusted at the behavior, to be honest.
Oh, yeah, this behavior is disgusting that you're asking me for something and I'm providing it. You say, can we flip it? And I say yes, and I show you, and then you bring up magnetics.
Okay.
You've been nothing but confrontational to say off and defensive.
Oh, boy.
All right, 1 second.
You're attacking what my belief is, but you don't have a good attack on it. So
Jeranism, your beliefs are ridiculous, and I'm exposing them.
Oh, yeah. My beliefs are ridiculous. You think the Earth's moving upwards, dude.
It's demonstrable fact.
Oh yeah, it's demonstrable. Yep, Earth's flying upwards. Yeah.
The difference.
Again, now Jeran just ridiculing me now. Like again, another way to just hand wave dismiss it. Like, oh, now you're claiming the Earth is rising upwards. Like, what's funny about reality is funny to you? Like, practical physics is funny to you? Like, what the fuck? Like, yeah, it's crazy.
I'm just wondering how he has so many subscribers.
I know. I mean, in my opinion, more than half of those subscribers are not even real. In my opinion.
Numbers are definitely being fabricated.
Whether bot accounts or just NPCs, just sheep, sheeple still. You know what I'm saying? Like,
maybe you can gift subscribers. You can pay for bot accounts.
I mean, at the end of the day, subscribers don't really mean anything. When it comes to truth, reality. Obviously. Shows who the liars are.
It's definitely not a number game. I'm just surprised if those numbers are real, that he has that type of following.
Yeah, I know. Obviously, it's bizarre with this kind of logic. Like,
I mean, with this logic, I don't know how he even came to a flat Earth.
Exactly.
It's quite interesting.
Yeah, I agree.
I mean, you as I can qualify my position. You clearly can't.
Sure, you can by just words and what you've been saying and definitions.
By physics,
acceleration.
By physics. All you have is a power trick of a Van de Graaff machine, and you think that qualifies it.
You asked if we could switch it, and I said yes. That's how we show you.
So what was asked is, can you flip buoyancy and density in a vessel? That being an air bubble rising through the water and a lead weight sinking in the water.
How the hell would you do that? You'd have to flip the polarity of the Earth. You'd have to just flip 100 meters. 100 volts per meter. Think of how high the Earth goes. So how am I going to flip that much electricity and put that on the ground and flip it the other way?
Right. So your claim's non-demonstrable. You can't falsify it. You cannot falsify it in any way, shape, or form, which is the exact same as the globe.
Show me something that moves upwards naturally out of nowhere that just does like the Earth you say it does.
What do you mean?
Well, you asked me to show you proof of so I'm asking you to show me proof that something can move upwards naturally with nothing's moving it up. It just happens to be doing that. So show me another example.
How's that related to the point that was just made?
I'm asking you to give me an example of your belief. And if you can't show me that it's demonstrable, you can't do it. You can't show it. Then you're just like the globe who can't show gravity.
My position can be demonstrated in any vector you like. I can change all the variables and I can change the direction, any direction you like. So that's my position. What?
So do it to the left then.
It's done.
How?
It's already done.
How?
By using motion, because motion's the cause of pressure gradients and buoyancy and density.
So how do you erase the downward direction when you move something to the right?
Because there is no downwards direction. Again, all these questions come loaded with the idea that there is this downwards bias already, this downwards vector. So it's like, how did you overcome it? How did you overcome this downward? Because there's no downwards vector. Like, what the hell?
How do you erase? So you're basically saying that in order for me to show you what I believe, you need me to cancel out the current thing and show you it in another direction, correct?
Yes, I can cancel out our position because I claim it because I can accelerate it to the opposite direction that it's going in, and I'll get an inversion of the effect.
So what's different? I don't understand what you mean. So how are you doing that?
By using motion.
Okay, so why can't you use a Van de Graaff generator?
because can you change buoyancy and density relative to each other, the direction that they go in using a Van de Graaff machine?
No, you need a more powerful one.
Exactly. You can. I can.
So you're saying you can show me acceleration and buoyancy change in any direction.
Again, that's literally like globe earthers when they say, well, show me an example of gravity or recreate gravity, right? And then they're like, oh, well, we can't because Earth's gravity gets in the way. We can't overcome Earth's mass because Earth is the biggest object, around us. So in order to overcome that force, we're going to need a bigger object or be in outer space. And now, Jeran uses the same logic with electromagnetism. It's like, well, we can't invert density and buoyancy because we have to overcome Earth's magnetic field or electric flow, right? Whatever, electrostatics, right? So to overcome that, we're going to need, enormous amount of electricity, which is impossible, in other words, So again, it's the same logic at the end of the day.
Yes.
Like to the left or right. So what do you explain that? I know you can't show me, so just explain what you mean.
I can, helium, you understand helium moves upwards. Yes.
Do you want to share a video, Del? Do you think a video demonstration could be?
Let me just hear what he's saying here. I'm trying to follow what he's saying. So,
okay.
Nat, you bring the videos up. You bring the videos up. Yes, I can use motion, Jeranism. So a helium balloon, which you would obviously understand, it's got a buoyant effect applied to it, pushing it upwards.
Correct. It's because it's less
so
density.
I can change the direction that the helium goes in by motion. So I can put helium into a vessel and accelerate the vessel in any direction, and the helium will move the direction that the force is going in.
But it's already going up, right?
But I can make it go down.
How do you do that?
By accelerating the vessel downwards. If I've got a jar with a helium balloon rising and a lead weight sinking, right, and I now accelerate it downwards, the helium balloon now moves towards the ground and the lead weight towards the sky.
Yeah, I don't understand what you're saying because aren't you just doing Go ahead.
Yeah, Del, can I show the video by Levelheaded William? Do you think that would be helpful?
Wait, you're talking about the water bottle with the sprinkler, with the spring in it?
No.
Okay.
No, not that one. The helium balloon in the fan.
The one with the spring's also a really good one to make the point. But yeah, Nat, show the video you want to show.
Show me. I don't think I'm following.
Yeah, it'll be short. I just kind of fast forwarded so you can see what's going on. William is going to explain it. Go ahead and watch it for a second.
Sure.
You need to get the bit before
have
that.
A cargo van as the container.
What?
You need to get the bit before that.
Well, okay. So I'll go back a little bit. Okay.
Okay.
Natch, you need to show him the bottle.
Yeah, I'm showing the bottle right here.
Yeah, you need to show that first. Yeah.
A water bottle as the container, and the camera mounted onto the reference frames that I'll be accelerating, which is the dolly. The reason why we have to constantly accelerate to recreate buoyancy is because we're connected to the Earth, which is already in constant motion. And in order to overcome constant motion, you need constant acceleration.
Can I ask one question?
As you can see,
so can you just real quickly explain to me clouds? So what's going on there?
Clouds are part of the density gradient, part of the pressure gradient. But, it's just like why helium rises, why we have these.
I mean, again, if that's not diverting, I don't know what is.
Just real quick, what about clouds?
Yeah. And, even though it has to do with why the helium balloon, again, in the second part of the experiment, why he's basically saying, what does in the back of the van hit the balloon? In other words, obviously there's denser air between, keeping that from happening. That's what's happening with the clouds, obviously. But yeah, again.
These layerings, these are all part of the system, and again, we can display how a pressure gradient and buoyancy and density is created by motion because the antecedent to these things is force, which is motion. So,
So I'm confused. So the cloud that's in the sky above me
Yeah.
It's the Earth is moving upwards, but the cloud is staying an equal distance away from me.
Yeah.
What is pushing up on the cloud?
What do you mean? What's pushing up the cloud? There's a layer of density of air beneath them.
Okay, well, if I hold a piece of paper out next to me, there's also a layer of air under it, but it will fall.
Yeah, because of the material that it is, the air can't push up against it. It can't to a degree, just like a parachute.
Oh, the air pushes clouds up, but it doesn't push a piece of paper.
Well, it does. It restricts its deceleration rate. If you make the surface big enough, if you utilize a parachute, you can change that variable and change the deceleration rate. It just depends.
I think you're being a Poe or something. You don't really believe this. There's no way you believe that a cloud is being pushed up by the column of air underneath it, but that doesn't happen to a piece of paper.
Well, what is a cloud, Jeran?
A bunch of water?
As a helium balloon gets pushed up. What's causing it to get?
A cloud is a gas. A piece of paper is, you could say, it's kind of a solid. Obviously, when you have a large surface area, that the paper just doesn't decelerate quickly because obviously the air is able to push up on it somewhat, so it decreases this deceleration rate. But obviously, when we're talking about a gas, that's way less dense than paper. So obviously, we're talking about two different densities that are affected differently by the air pushing up. So I don't know, that's pretty simple to understand. So I don't know what he's, where the problem is, I guess.
It pushed up.
It has less density than the air it's in.
And what does density have to do with motion?
Because there's displacement. Where the fuck is it going to go?
Well, what's pushing it up?
Nothing needs to push it up. The air underneath it pushes it up.
Well, exactly.
Right.
Right. So you've just answered that the air's pushing it up.
Right. So a piece of paper, if I hold it.
Again, the air's pushing it up, exactly. But we know inanimate matter or matter on its own cannot move itself. So what's pushing the air up? That's the question. Because again, the air cannot push itself to be able to push other things like, helium balloons and stuff like that. So, that's the question. Obviously, motion being a chain reaction, force, the air's obviously being pushed up by the ground. What's pushing up the ground, which is a lot of people's question. Well, nobody's been outside of the earth to know what the mechanism of the earth's motion is. So that's, we can't know everything about this reality. And that's probably one of the things that we can't know. What's the force or the cause of the earth or the mechanism of the earth's motion? That's probably just going to remain always a mystery. We don't know. So it's irrelevant.
And it gets a little irritating that because that question cannot be answered, that they then think they can go ahead and dismiss all the demonstrations and all the other physics that come with it.
Exactly. It's flawed logic. Again, you don't dismiss level water because you can't go to outer space.
Again, you're basically saying you're telling your bias without having to say it.
Exactly. Just like globe earthers too, that they denied level water being in front of them measurably, testably, because you have to go to outer space. You have to be outside of the earth to be able to see, the whole,
Yeah.
it's flat or whatever. So again, flawed logic.
But here,
Uh-huh.
it falls because it's more dense in the air, correct?
Yes, because the air can't push it up.
Why not?
Because you just answered that.
No. I'm talking about your model. You say the ground is moving up.
Yes.
Clouds are staying an equal distance away from me. You're saying that the reason that the cloud is being pushed up and staying in the same exact spot is because of the column of air underneath it's being pushed up, yes?
Yep.
So why isn't the column of air lift the piece of paper?
Because it's too dense.
Okay. Well, then it's the same belief I have.
Okay.
So you believe clouds are denser than the air beneath them?
Clouds are denser than, no, they would fall.
And that's what I'm saying. So it's obvious the clouds are less dense than the air beneath. The paper's more dense than the air that's surrounding it. So the air's pushing past it. It can't keep pushing it up.
Okay. Can I just interject real quick?
Yeah,
we can continue with this.
Okay, go ahead. Sorry.
Yeah, that's fine. Like basically, like your position, Jeran, if the Earth is continuously pushing up, then we would be like getting closer to the clouds, as far as I understand that what you're asking, right?
Well,
and what I think
the clouds and the stars and everything, yeah.
So what Dell is.
Sorry.
Go ahead.
Can I just clarify? I need to ask a question. Is it your position, Jeranism, that the Earth system and the things that we call the luminaries, the heavens, are all separated?
We are the basement of the universe, and everything rotates around us.
And are they separate from each other?
Are they separate from each other? I don't know what you mean. They're all part of the world, but are they separate like the star isn't connected to the Earth? Yes.
So they're not connected to the Earth?
Correct.
How did you
maybe
start
energetically?
So you believe then that the stars, the luminaries, are separated from the Earth?
Do you mean energetically or do you mean physically?
What do you mean? What's energy?
I don't know. Energy is force from a distance.
Right. So force. So force is a connection between two things.
I think that the stars might have effects on us. Yes. So I don't know what you mean by connected.
Well, is there a void between the Earth and the stars?
A void is in a vacuum?
Yes, like nothing between them.
No,
nothing connecting
probably some liquid that they're in.
Right, so that's what I'm saying. If I have a vessel with lights above it and water in a tank and I push it upwards, then they're all connected. So why would you think one would crash into the other?
Well, because if you're talking about the air being what is connected and then the whole bottom is moving up, then all things would be affected by that same column moving everything up.
Yes, and they are.
Right. So an airplane is moving up when it flies by the air below it, even though it's more dense in the air.
Well, the airplane's using constant thrust. It has to keep using thrust in order to maintain that distance. Like a helicopter uses thrust to hover above the Earth.
Correct.
Do you think if we were in an elevator moving upwards and I took a drone off and hovered the drone, that the bottom of the elevator is going to hit the drone?
No, it's operating within that system.
Exactly.
Okay.
Right. So there's your answer. So let's continue with the video.
So, but hold on. But if you dropped a drone, it would fall and hit the ground, right?
Well, the drone would lose its momentum upwards because it's moving upwards with the elevator. So the drone would slow down now and the bottom of the elevator would connect with the drone as the drone still moves upwards.
Yeah, I guess what I'm saying is I think you're just taking a contrarian position. You're just saying that the things that it's kind of like what Albert Einstein did with relativity. Please don't
strawman me.
What?
Please don't strawman me and just call me a contrarian.
Okay, let me call you something.
Qualifying everything that I'm saying. I'm speaking to you.
Everything by saying it's equal. It's equal and opposite. Like basically, Einstein said that you could either call it gravity or you could say it's the opposite. The Earth is moving up at 9.8 meters.
Yeah. Well, in Einstein's equivalence principle, which is the similarity between the globe Earth and the stationary Earth, in Einstein's equivalence principle, he talks about how if we were in a moving reference frame linearly, or we were in a gravitational field, there would be no way for us to tell the difference. Right? However, one of those is demonstrable and one is not. We can utilize motion, linear motion, to demonstrate these things. We do not have access to gravitational fields, things that can accelerate uniformly gas, liquids, and solids. These are mathematical propositions. It's an interpretation based, which is what the globe has done. The globe required physical downwards acceleration. So it takes optical phenomena, that being Neil deGrasse Tyson letting a mic go and saying gravity, see. Right. So optically, they interpret that the microphone went downwards and then start claiming from there's a physical downwards acceleration due to this imaginary field. Now, in the equivalence principle, one postulation, that being motion, physical motion, can be demonstrated and can recreate the conditions of our reality. Nobody can demonstrate a gravitational field. Nobody can manipulate a gravitational field. Nobody has access to this in any way, shape, or form. It's a mathematical proposition.
So you're saying that all gravity around the Earth is the same?
No.
Okay. So if there's a change, aren't they representing that? Aren't they showing that?
Yeah. Well, we've got air, right, and we've got fluctuations in the air. So you understand that if I'm on a scale inside a vacuum chamber and I weigh 18 stone. Now, as they vacuum the air out of there, my weight increases because the upward push, the buoyant effect, is no longer felt anymore. So we get an increase in what we call weight. Now, as you move around the Earth with fluctuations in temperature and pressure, you will get microscopic variations, which is what they get. Microscopic. depending on your altitude, air temperature, and air pressure. These things play a role.
Right. So why does the electrostatic explanation of that not work?
Because the electrostatic explanation is one and the same. I cannot detect the physical downwards acceleration other than to interpret it as an optical phenomena. When I test for it physically, no detection of that acceleration is present.
But can you detect that there is a change in the electrostatics?
What do you mean?
If we went up and checked at 40,000 feet, would there be a different voltage than at 5 feet?
Probably.
Okay, so then
I don't know what that has to do with the physical downward acceleration without displacement.
I'm convinced he's buying time to not play the demo.
Right?
It's been so long.
Oh my god, I forgot that they're supposed to play the demo. That's true. Oh my god, it's been so long.
Like all of this just because he wanted to avoid playing the demo, like the demo. He just immediately cut him off. I was like, what about the clouds? And then look at where we're at.
I know, like 15 minutes later. You know?
That's why it's very important to keep bringing them right. It's fine to answer them, I guess, but it's important to bring them right back to the topic right after.
Mhm.
That way it stays on topic, because look at how far they take it. I mean, people in the comment section do it all the time.
Yeah.
And they'll keep going if you don't bring it right back.
They just have another question after you answer this one, and another question,
which is
and then another
irrelevant to the topic at hand.
Exactly. Yeah. They're trying to avoid basically
Yeah.
the topic.
did verify that there is a gradient of
Again,
electrostatic force. Okay.
Well, again, no, there's a gradient, but a gradient, the antecedent to any gradient is motion. Look, I don't discount electrostatics in any way, shape, or form. I'm trying to get people to incorporate it into the investigation. It's simply not the cause of our conditions. Again, if it is the cause of our conditions, then you should be able to demonstrate it. But you
It's not
can't.
the cause. It's not the cause of the conditions.
Right, so what causes the conditions?
There has to be a down.
There has to be a down.
Correct. If you're going to have
Right.
displacement and things have to go in a direction, then they were going to.
I mean, if that doesn't show that you have a bias, like literally, there has to be a down. Like literally saying there has to be a downward vector, because my belief requires it. So there has to be, like, even though reality is showing otherwise,
Yeah, it has to be well demonstrated.
Exactly. That's the whole point, of this discussion, of the demonstrations, of these claims.
I'm not sure where they think that their words triumph the demonstrations.
Again, just deceivers. That's what deceivers do. They hope that their words, are good enough to convince people, about their reality.
But words over demonstrations will never make sense to me.
Exactly. But obviously a lot of people are not really thinking straight.
Well, they're easily swayed.
Exactly.
They see how his numbers on his channel.
Mhm, Again, that's where all these numbers, all these subscribers could influence real people. Even if they're not real.
Yeah, but the channels with the numbers are avoiding this topic,
Exactly.
avoiding talking about objective reality, just focusing on words and what they believe matter or doesn't matter, or history and
exactly.
Like
A lot of bullshit.
just stories,
And avoiding the simplicity of the reality that debunks the globe. Literally.
Like, let's not get into this. It's silly, but let's go into all this history and all my beliefs and all this other stuff. Like that doesn't make sense.
Exactly. Yeah. If that doesn't show that they're being dishonest.
If your bias was fact, you'd be able to demonstrate it.
Mhm.
And instead, they're trying to run around in circles, trying to avoid having to demonstrate whatever their position is.
Exactly. Again, double speaking. It's
Yeah.
accelerating, but not accelerating.
Yeah.
It's not a force, but it acts like a force. Like, it's crazy. Crazy.
Go one way, one direction or another, and whatever direction everything goes in would be where we would stand, and we'd be having this conversation talking about where down is.
Right, but down's just our directional.
That's what my point was: is that it could be any direction. We would just be there, living there, calling it down.
Yeah, but it's optical. That's the difference between optical and physical.
Right.
So again, optically, you can interpret down, things go down, but physically, it's not there. That's not what's happening. Just like optically, I can assess that, the sun appears to go down, train tracks appear to converge. These are visual interpretations. When we move through these things physically, like a train track, we have provable integers that are directly measured, showing that the train track spacing does not alter. So we know optically we have an issue. It's optics that's causing that phenomenon, not the physical world. So the same when we drop things, we have an optical interpretation of physical down.
Okay.
But physically, it's not there. It's not actually what's physically happening.
Because why? What's your evidence of that?
Because it's not detectable.
It is detectable.
It's
We
not
see that it's going
detectable.
down. We wouldn't even be talking about it if it wasn't detectable.
But optically,
Did he
Jeran,
even listen to what he just?
relative to you, optically,
He literally said, you're going off observation. Optically, that's what it looks like. He's like, but isn't that what we see? Like, you're not, are you listening?
He literally just said that visibly, yes, that's what it looks like. He even agreed that that's what it looks like. But physically, that's not the case. And it's like, he still keeps going back to that same response again. Yeah, it is a little bit frustrating. I'm surprised, they'll entertain this conversation as long as he did. But
I mean, it kind of seems like he's trying to trigger him too at times, But I mean, Dell's doing a great job of just staying level-headed and entertaining his back and forth. I guess.
Is diverting questions, basically.
Yeah. But still, the demonstration still hasn't played.
I know.
It's
That's true.
just-
The demonstrator still hasn't played. So we'll see. We'll see if I think it does play, right? I don't know. Remember if it plays completely through though. I don't know. We'll see.
It's been like 20 minutes maybe.
Yeah. Avoiding
Diverting.
in your coordinate system of optics, you're the stationary point. You're the point of reference. So you're saying down is a direction relative to you, up is a direction relative to you. That's your coordinate system.
Okay.
Right? Physically, it's not what's happening.
Okay, but you're just going to say that we're moving up, and you're going to put yourself into the world, and you're going to say the ground is moving up in this, right? So you're just saying
Because I can detect that.
Just like we could detect a change of anything dropping.
Yes, there's a change when we drop things. There's a change in velocity.
Okay.
Right, but the claim of a vector is the important part. So nobody disputes that when I let an object go, there's a change, right? The claim is that the change is that the object physically accelerates downwards. That's the problem.
The claim is it falls downwards, yes?
Yeah, but with the claim attached to that it's accelerating downwards.
Again, you're just using words that may not be described.
No, you're just using words like fall.
Instead of accelerating downwards,
Exactly.
it's falling.
It's falling.
But what does falling mean? That it's moving towards the ground is what that's what falling by default means. That it's the object is moving towards the ground.
From stationary.
Yes, from stationary, exactly.
Yeah. So again, it's an acceleration.
Yes.
And no, it's fine. Then he tries to tell them, "Oh, you're just using words." It's like, no, that's exactly what you're doing. It's crazy. Like, there's no way this is not delivery.
See, that was being precise, and then he goes and uses a word that's like open-ended, or that's not specific.
Yeah.
Describing exactly what's going on. If you're talking about acceleration, do you mean it constantly accelerates?
It's the vector that's in the question. Nobody, listen to me clearly. I do not, just like you, deny there's a change when I.
Well, they put the video down again. I don't remember if it even played through at this point, but we'll see.
I don't know what happened.
I know. I don't remember. We'll see.
I let an object go. Okay, we clear so far.
Okay, yes.
Right. The problem is that from, say, your position, when I'm sitting here holding this object in my hand right now, it's stationary. Correct?
If you're holding it, yes.
When I let it go, does it go from stationary to moving towards a stationary Earth?
Yes, but let me just see something. But aren't you just saying that the same is true, only you're saying that the ground is moving up? So you're just saying the opposite of the thing falling and hitting the ground is you're just saying the ground moves up.
No, that's not what I'm saying.
Okay, explain to me what you're saying.
When I'm holding the object, it's moving at the same rate as me in the reference frame. When I release the object, it loses that velocity.
Which causes it to optically look like it's moving faster.
What do you mean? Yes, it's an acceleration. It's a change in velocity. So optically, the optical part is people interpreting that the object physically.
Again, the gap between the Earth and the free-falling object increases by the second. Like the distance being covered between the two objects increases by the second, but that's because this is decelerating. Therefore, the Earth's constant speed is able to catch up in the faster in the second than it did the first second, because it has a slower speed now in the second. So the Earth is able to catch up faster in the second than it did in the first second. Again, that optical observation could be interpreted as an acceleration, of the object, in free fall if the Earth was motionless. But the fact is, again, you will get the exact same results if the Earth was at a constant and the object was decelerating, per second, so.
Moves downwards, not optically, physically. Let's separate it.
Okay, why can we not say the same thing when I drop an item?
Say what?
That it's falling down.
Because you're claiming that that's a vector.
No, I'm not claiming that. I'm just claiming it's falling down.
Yeah, but right. So let me clarify your position.
Okay, if you want to just use the word fall as in like open-ended, then yeah, it's falling down as in it's falling behind. How about that? It's falling behind from the upwards motion of the Earth.
It's like the push-pull thing. You can use pull as a
description
of direction,
exactly.
But nothing is being pulled; it's being pushed.
Exactly, it's not a mechanism. Yeah. Pull is not a mechanism. So again, fall it's not something different from an object being either accelerating, decelerating, or constant motion. And the fact is it's decelerating, measurably.
You then claim that I let the object go and the object moves from its position it was in towards the Earth, correct?
Yes.
Right. So from stationary to moving is an acceleration, and it's a direction.
Yeah, it's 3:45. It's too much for me. I don't even know. I don't get why we're just having word arguments over. You keep bringing in acceleration, and then we have to almost surmise things because you use that word. You're just playing into their traps and playing into their words. This is the problem I had with Bob. Bob always said F equals MA. And he would say that's like a universal. We can't change that. I'm like, no, that's man's interpretation of things.
No,
again, he's literally accusing Dell of exactly what he's doing. Again, all you're doing is man's interpretation, of things, and using these words and interpreting to fit where you want them to fit. And it's like exactly what you're doing with falling and your, interpretations, your beliefs, your rhetoric to defend your bias of a downwards acceleration on your stationary Earth. Like that's exactly what you're doing. Just because you're accusing Dell of that doesn't mean you're not doing it anymore. That just means, in my opinion, that you're aware of exactly what you're doing. So you're gonna accuse the other person of that, so that so it could look less likely that you're doing that.
Either that, or you're used to the smell of your own shit.
You
can't even detect it.
That'd be some crazy shit. I wouldn't be surprised, at this point. Especially if you're monetized, and you have all these subscribers and views. I can see how that could get to your head, But man.
When Bob said that, in regards to language, I mean, again, you're straw manning me, Jeranism. It's very, very simple.
I wasn't talking about you, so how am I?
But I'm going to help out. What Bob said. F equals MA, and it may help you to comprehend this. And I hope I'm not being condescending, but I think there's a real lack of comprehension.
Maybe.
So F equals MA. Force equals mass times acceleration. So when you understand the use of language, all we have in reality is physical change, motion. Okay? So what we observe is motion of matter, a change. Now we quantify that as the word force. So force is ascribed to mass times acceleration. So they quantify force by how much mass moved over a particular distance and how long it took. Right? That's all it is. So what they're actually...
There is no force. If you're talking about dropping an item, they say there's no force there's no acceleration in free fall.
Mm-hmm. But that's the problem that I'm trying to convey to you.
I would agree, Simple Mind, that he is trained in to lie and use distractions. I mean, he was able to distract from the demonstration video that they were going to show, like by asking about clouds and then asking a bunch of other questions.
No, and then he went on to play. Oh, you just want to do this? What are we doing? Just using all these words? And it's like, well, there was a demonstration that was going to be played, but you disrupted with clouds.
And then they didn't get shown, and
here we are in no man's land talking about
who knows what. But way to distract. So yeah.
If an object's stationary, whether you're on a globe Earth or a stationary Earth, and then the claim is that the object moves, there has to be force, because matter does not move by its own volition. Force is the thing external to matter that presses upon matter and makes it move.
Yeah, I just don't believe that. I'm sorry. I mean, you could drop an item, and I don't believe there has to be a force. That you dropped it, you let it go. If you want to call that a force, that's fine. But from there, the item will accelerate because it's moving. It's momentum.
Momentum's a part of something already in motion. How can you have momentum of a stationary object?
I just said you dropped it, you let it go.
So what makes it move?
Exactly. Momentum doesn't create itself.
He's
Motion.
like a glober. I dropped it and let it go.
Like, okay, that's not a force. You dropping something like this, you know. It's crazy.
It's denser than the air it's in.
So density is a force.
Sure.
Right. How are you going to qualify that?
Well,
Extract force from the density then. Show me how you do that.
Because there's disequilibrium, which causes a change. It has to displace. It's not in equilibrium. So it has to go in a direction, and it goes in the downward direction.
That's just an assertion. It has to. This is physics. Physics is when an object matter moves because something external pressed upon it to make it move.
What about when I drop an item? If I'm holding an item and I just let it go, you're saying where's the force that's dropping? My hand releasing something now is the force?
No, I'm not claiming that it's going down. That's your problem. I'm claiming that it's still on.
Help me figure out my position.
Yeah, that's what he claims. That you releasing an object is a force. Like he's trying to make it seem like that's what Dale claims now. Trying to make it look ridiculous.
He's saying that, but then he's also saying it's density, and it's like, what yeah.
Is it you dropping it or density?
And then if it's density, why does it disappear in free fall? But that's its time to shine. Like it just.
Yeah, again, running around in circles.
Like I don't know how people can't see this. If you know, I mean, anyone being honest, anyone genuinely interested in this should be able to see it.
Anyone that's honest with themselves, for sure.
Yeah, it's just
bizarre.
It's way upwards and losing momentum because there's no force acting on it anymore.
So things basically all float.
No.
If I hold a rock out in front of me right now and I let it go, it's floating.
No.
Where's he getting that from now?
Again, if the Earth is in upwards motion at a constant speed and I'm holding this and I'm connected to the Earth, then this is also moving. Everything's moving at the speed of the Earth. When you let this go, an object cannot go from 100 miles an hour, for example, to 0 in an instant.
Mm.
You know, you need time to decelerate, especially, who knows how fast the Earth is moving. But again, an object's not going to just be motionless the instant you release it. It's still going to be in its upwards trajectory, but losing momentum. So again, that's a straw man argument to claim that the object is motionless when you release it and the Earth accelerates up. Again, it's a straw man because they're trying to pigeonhole people into, if you claim that that object is motionless in free fall, then by default, the Earth does have to accelerate up, which is ridiculous because then obviously our weight will have to increase into infinity. We wouldn't even be able to walk or move, so that's retarded. So to claim again that an object is floating, in my opinion, is being disingenuous and trying to strongman into claiming that the Earth is accelerating up. But the fact is, again, objects decelerate, they have to lose momentum from the constant. And that change in velocity is what we would call acceleration. But again, it's the Earth that's at a constant motion moving up towards a free-falling object. Yeah.
It's funny how Witta said the exact same thing too.
No, yeah.
So it's just floating.
Yeah.
But it doesn't make sense for Jeran because you were just participating in this entire conversation. Where did you get that that's his stance all of a sudden?
I know he did explain that deceleration, a loss of momentum multiple times before this. So for him to say that
decelerating doesn't mean floating.
Again, it's either he's not paying attention, he's not listening, or he's at it. He's being deliberate with his questions and assertions and stance, in other words.
I mean, there's one that's pretty obvious to me, but
yeah.
Everyone has to come to their own conclusion.
Exactly. You could take the horse to the water, but you can't force them to drink. Again, you can show people the flawed logic and all this, but you can't expect them to get it. It's up to them.
If the same thing that comes with this topic and not any other truth is you have to use your own discernment.
Yeah.
Others can't discern for you. You have to learn to trust and use your own discernment. And this is part of the process. You have to come to your own conclusion. You have to do the research for yourself. Don't listen to any of us. It's just.
understand reality for yourself.
Yeah,
At the end
it's
of the day,
part
because
of
this
it.
is an objective question, you know, what the Earth is. So when it comes to the Earth and physics, you know, understand it for yourself.
Yeah, you shouldn't just agree with something just because that's where, you know,
The crowd's
the
going.
crowd's going. You need, if you don't understand something, don't get on board with it until you do.
Exactly.
But also don't sea lion and pretend like you don't get something just because you have a bias. And it's okay to admit you have a bias, but this topic of conversation is probably not for you because, you know, it's this is objective reality. You can't deny physics.
Exactly. You know, reality is what it is at the end of the day. Either you get on board with that or you're going to be left behind.
And that's fine. I mean, not everyone's going to get it. There's a lot of people that, you know, unfortunately pass without getting it. You know, it's just, you know, I hope a lot of people get it though.
Hopefully they come
Obviously,
around. You know?
I think it's pretty simple enough. I think the demonstrations are pretty clear. I think people are articulating it well. You know, I do believe that the more people that can articulate it should, because we all have a different voice. We all articulate things differently, and the more people doing it can reach different crowds. And the way you say something can resonate with someone else that wasn't resonating before, the way someone else said it, you know. So never underestimate the power of your own voice, and, you know,
speak out. Yeah, that's the only way this is going to move forward is for people to speak out. And, you know, we're seeing it, slowly but surely, you know, people are getting it, people are articulating it, which shows that they're getting it, you know, and that's great. You know, the more and more we push, again, no pun intended, the more and more we push, you know, this information forward, the more it's going to reach people, you know.
Yeah, it's not going to change unless more people change and speak, and not just change, but speak out. It doesn't have to be online either, just within your circles, your family, you know.
Again, at the end of the day, it's about the individual, you know, so again, people have to take personal responsibility and, you know, and go from there.
Well, if the ground is moving up to meet it and it's not falling, then what the fuck is it doing?
Still moving upwards. Listen, see if I'm in a glass elevator, right, and I'm standing in a glass elevator, and you're outside of the glass elevator, and I'm holding it.
Del, you're free to believe the Earth moves up. Have fun with that.
I'm trying to clarify Jeranism, right? Because
well, I disagree with your belief. Get over it.
Let me qualify, right? If you're standing outside observing me in a glass elevator moving upwards, and I'm holding an object in that glass elevator, and I let the object go, you see from the outside that the object I dropped still moves up, right? But what happens to me inside the reference frame is I see it visually as if it goes down, but it's still moving upwards at a slower rate than it was in the first place.
Okay.
So that's what I'm saying. When you let an object go, like if I'm holding a glass of water,
what I'm saying is you can just say you're just saying the opposite. You're just saying
no, I'm not.
Okay.
No, I'm not. I can qualify every single thing I'm saying using physics.
By completely just opposites.
No, by demonstrating it physically.
It's not demonstrating if you're just doing the opposite of it. You're just saying, oh, it's not actually falling, the ground's moving up.
Wow.
That's what you're saying.
No, it's not what I'm saying. You continue to strawman me through this. I've not done that once to you.
Yeah, not once. So if you're saying that, if I'm saying an item is dropping, you're saying, no, it's not, the ground is moving up, correct? That's just your claim on everything. So
no,
you can believe that. You mean no?
Because Jeranism, let's get back to your point again.
I'm standing here and I've got a rock and I drop it. I'm saying the rock has density. It's going through its medium that doesn't hold it up until it hits the ground. You're just saying, no, that's the ground moving up with everything and it's going to meet the rock.
So let's clarify. Is density a force?
Jesus Christ.
Well, if I'm standing here with an object, right, and it's stationary, has no vector, right?
No, it does have a vector. Every item has a vector. Every item is going down, my friend.
Yes, and a vector, the antecedent to a directional vector is motion, Jeranism. It's the antecedent.
The antecedent to a vector direction is what?
Motion.
This is not getting anywhere, gentlemen.
Yeah,
we are. But do you mind just? Can we just show the video and then talk about it a little bit, and then I'll let you go. Yeah, can I like 8 more minutes?
It's not getting anywhere, and it's like, yeah, because it diverted from the demonstration.
And he kept asking, like, oh, do you have a demonstration of recreating this? And Dell was like, yes. And now they're going to show it, but again, he completely diverted. So we'll see if it does play again. I don't remember if they do go through it.
I just wanted to address Dojo's comment real quick
Which one?
about you'll never defeat the Christians. The Bible tells them the earth does not move. Good luck. It's not about defeating anything or anyone. I mean, it's objective reality. What was the other part? Where was that? You'll never defeat the Christian. The Bible tells the earth. Oh yeah. Again, it's not about defeating anyone. At the end of the day, religion is a belief. You get to choose what you want to believe in. That's why there's so many options. That's not objective, So anybody that's like a Christian, no offense or anything, but you're in a belief system of some sort. So I mean, yeah, there's nothing to defeat. They have a belief. This is objective reality. They're choosing their belief over objective reality, and that's their choice.
Again,
I'm uncertain what there is to win over that.
Again, if they have this like winning mentality where again they have an idea and they're trying to beat the other idea, again, when it comes to objective reality, that's irrelevant.
Minutes maybe, and Adele, just hold on tight, please. Let's just watch this video real quick, and then I'll let Jeran go.
Centered, which means the bottle is level, and the camera mounted onto the reference frames that I'll be accelerating, which is the dolly. The reason why we have to constantly accelerate to recreate buoyancy is because we're connected to the Earth, which is already in constant motion. And in order to overcome constant motion, you need constant acceleration. As you can see, the air bubble is centered, which means the bottle is level and at rest. The air bubble will always be displaced or pushed relative to the motion of the bottle. When I accelerate the bottle, the pressure of the bottle pressing on the water creates a pressure gradient. The water is then able to push anything that's less dense, like the air bubble, in the direction of acceleration, which is what we will call buoyancy. You can't have buoyancy without a pressure gradient, and you can't have a pressure gradient without a contained system that's in motion. For the second buoyancy experiment, I have a cargo van as the container, a helium balloon, and an apple. I also have the camera mounted onto the reference frame that I'll be accelerating. As soon as I accelerate, the pressure of the van pressing on the air creates a pressure gradient, with the most dense air towards the back of acceleration and the less dense air towards the front. The air is then able to push the helium in the direction of acceleration because it's less dense, but the air cannot push the apple because it's more dense. Therefore, the apple remains at rest. The apple only appears to move in the opposite direction of acceleration because the camera is also moving with the reference frame. The helium balloon has true motion, and the apple has apparent motion.
Wait, what? This is false.
This is the point. This is the
Okay.
thing. This is the bit that
Okay. Now, 1 second. Let Jeran speak. Can you explain
you
what
try and explain that to me, Nacho? So he just said that he's showing the movement of the balloon, and then he said the apple's not moving when clearly it was. So can you rewind it or explain what the hell he's talking about?
Because you don't understand the visual interpretation.
And that's why I'm asking. That's why I'm asking for an explanation, Del. When people don't understand, they ask for an explanation, dipshit. That's what I asked.
I'm going to explain it to you.
Okay, gentlemen.
I asked Nachi to just. I can't even understand your language, dude. So Nachi.
Yeah, now, one second.
Your language.
Your son.
That's not an insult. That's called a fact. I can't understand what you're saying. Do you
I
not
can't understand
Oh,
I can't understand your stupid backward reasoning. But I'm still here.
Oh well, sucks to be you.
Gentlemen, 1 second. 1 second, gentlemen. Okay, Jeran, can I explain to you what I see? So we just go back a little bit, and then I will pause it, and then I will explain what I understand. Okay.
Therefore, the apple remains at rest. The apple only appears to move in the opposite direction of acceleration because the camera is also moving with the reference frame.
Okay. So what I believe that William is saying is that it appears like when you look at the this. So like it actually the van is moving, but the apple is maintaining its position. So if the van is moving to the left, right, its original position was in the middle, right? But as the van is accelerating to the left, it still maintains its position in the middle, relative to its original position. Does that make sense, Jeran? Did you understand what I said?
I mean, I guess, but it's held by a string.
Yeah, but I mean, like, obviously, it's held by a string, but like, it's moving in the opposite direction to the acceleration because that is its original position. It's trying to stay in its original position. Does that
Okay.
Make sense so far? That's what he's
in the
talking
real
about.
world, I see what you're saying. So you're saying the apple's maintaining its spot in the real world, even though it's held
Yeah.
by a string. So because otherwise it would leave out the back of the van, right?
Yeah. It would, I mean, it would be it would have to be rolling around the floor of the van, I guess. But this is just for visualization.
I get it now. What he's saying.
And then okay, good. And then Del, do you have anything that you want to add or clarify based on what I just said here?
Yeah, it's exactly that. And if you invert that, that's what I was trying to explain earlier. The apple
Okay.
now, the apple now appears as if it goes the opposite direction, so that would be falling. But in reality, the apple's not. The helium balloon's the actual thing that is moving because there's a pressure there. It's being accelerated towards the direction of the acceleration because it correlates. The less dense material will be pushed in the direction of the acceleration.
Right, but so I guess where I'm confused is that if it's a van of air, right, which is what it is, then everything that's happening is a result of the air being shifted, right?
No, the air stays.
Correct.
The air stays where it was, and there's a compression of the air.
Air.
Yes, the air stays where it was. The van's the thing that moves. So there's
again in the van, it's basically moving the air as well in that same direction the van is moving. And in the air, again, anything that's less dense in the air, it's going to get pushed in the same direction as well. It's very simple to understand. And you can recreate this effect again, like I showed in the video earlier, with the container with water and a ping pong ball. Again, when you accelerate the container with water, a ping pong ball is less dense than water. We get the same effect of the helium balloon right here. It gets pushed in the direction that the container is moving. Again, that is what we will call buoyancy. Again, you can recreate this using different states of matter, different containers, and accelerating in any direction. You're going to get the same effect every time.
a compression of the air towards the back of the van, the opposite direction of the acceleration, which causes the buoyant effect, pushing the helium balloon forward. That's how the displacement happens.
The air doesn't travel with the van?
No, the air has inertia just like the apple. So the air stays where it was relative to the van, and when the van moves, it causes a compression of the air at the back of the van, which causes a displacement of the helium, pushing the helium forwards.
Okay.
I mean, okay, before you say, okay, does it make sense to you? Like, for example, like if you look at this van, like the apple and the air are going in the opposite direction. And because the air and the balloon have a relationship, and the air is compressing to the right, and that's why the helium balloon, being less buoyant, goes to the left. Does that make sense or not?
Yes. Did you say that backwards? The helium balloon goes to the right, right?
No, the helium balloon goes to the left, according to our perspective. The air is trying to maintain its.
Isn't the car going forward? Isn't the car going to the right?
The car is going to the left. The direction of acceleration is to the left. Look at the arrow.
I see the arrow.
Look at the arrow.
I was just looking where the driver was. Okay, gotcha. So he's backing up.
Yeah, it's backing up. He's backing up. So the apple and the air wants to stay in its relative position, which is in the direction away from the acceleration, and the balloon is going towards the acceleration because the buoyancy relationship between the air and the helium balloon. I'm not sure if I can. If Del agrees. Del, do you want to add to that? I mean, does it make sense what I just said, or do you want to clarify it more?
Yeah, it's due to inertia. This is the whole gambit. When there's force applied, we see this gradient created because the inertia of all matter, is prevalent. So as the inertia of the air takes effect, it causes a compression, which creates what we call buoyancy and displaces the helium.
I guess where I'm confused though is we can't turn this sideways and do it, because if we did, then the apple's no longer connected to the roof.
Yes, we can do it in any direction. It's all been done. Jeranism. We've done it.
I just explained why you can't. So instead of saying you can do it in every direction, correct me. I said if we turn this van to say facing upward, then we have a problem because the apple can no longer be tied to the place that's tied.
Yeah,
How's the apple gonna sit there?
It would have to be tied in a different way. It would have to be tied in a different way. Like if you're talking about just flipping at 90 degrees and then it's like going upwards and it's like a rocket, then you can still create a pressure gradient. No.
Yeah, but I'm saying the activity that's happening here is happening because there is a downward direction. That's why the apple's hanging. That's why the
Again, he's going back to the default. It has to be a down. There has to be a down. So we're getting these conditions when we have to time them in this manner because there's a down. And it's like, again, it'll be the exact same effect with the Earth pushing up. Again, you will get the displacement of the helium balloon being pushed up and the apple appearing to go down again because of its inertia, and the air is not dense enough to push the apple. So again, this effect of him saying that, oh, it must be a down because the helium balloon's already trying to go up and the apple's trying to go down. Is again, we get the same effect if the Earth was pushing up. That's what's in question. What's actually happening? Because visually, you're just claiming that it's what you want it to be without any practicality behind it. But it could be either or, and that's where these tests, the practical shows that it can only be one, and it's up. It's the Earth pushing up,
balloon is attached to the bottom of the van. It's all dependent on either the gravity or the what we would call density and buoyancy.
But see, the thing is, so if you take it on the vertical, the up and down thing, right? So if we have the van like that, we have the apple at the bottom of the van, and we have the helium balloon on its way up through the van towards the sky. Okay. Now, if we start moving that van upwards towards the sky faster, the helium balloon rises faster.
Okay. Because the air is being pushed to the bottom.
Yes, because the air's compressing at the bottom, like on the Earth. That's why we have a gradient of air here, just like in the van here scenario.
What would the apple do?
The apple would remain where it is because the air can't push on it.
Yeah, but
so
it's go ahead.
1 second. So Del, let's just imagine a rocket, that it's accelerating down to the Earth, and you have unlimited amount of space, right? And there's air and balloon and an apple inside that rocket, just like a container would, like this container would. Then would you surmise that because it's actually accelerating to the ground, and it's going faster than, let's say, gravity pulls it, it's actually going faster because it's a rocket going downward. Would you have the same effect of the density gradient where the balloon is actually towards the bottom, pointing towards the ground, and the apple actually will be at the top in that gradient? Yes or no?
Yes, this is what I'm saying, that we've done all this, downwards acceleration and an inversion of the buoyancy.
Again, let's go back to the examples of downwards acceleration and seeing the inversion. Okay, this is what downwards acceleration looks like in the inversion of density and buoyancy. Again, when connected to the Earth, you can see the steel ball appearing to go down and the air bubble being pushed up, again, showing that the force is up. And when I actually accelerate this down, you can see the inversion of density and buoyancy. Oh, here, let me share this tab. I almost played it without sharing the tab. But yeah, this is what physical downwards acceleration actually looks like. You see the inversion again. The air bubble goes down and the steel ball goes up. This is another drop test, acceleration. Again, you see the inversion. The air bubble and the steel ball move in opposite directions. And again, this is free fall versus actual acceleration. Again, simple.
Density.
Yeah. Okay. All I needed is all I need. 1 second. All I needed is a yes. Jeran, do you think that's possible or that's plausible, or do you disagree with that idea?
So go ahead and lay it out again. There's a rocket. It's coming down towards the Earth, and it's got inside of it a helium balloon that's got no string. It's just a helium balloon.
Yep.
Yeah, just a helium balloon, air, and an apple, and then it's moving down to the Earth faster than the gravity can actually pull it. So it's going faster than the free fall.
Okay, so gravity. So then the apple would be pressed to the top.
Yep.
Okay.
And the helium balloon would be probably at the bottom because the helium balloon is less buoyant than the air, which would be pressed to the top, just the same as this experiment right here.
Okay, I agree with that.
Okay, good. Then we both are on the same. We're all on the same page with that, right?
Okay.
Okay, Del, did you want to say something more?
No, I mean that's the whole point. This is how accelerometers work. This is what it shows us when we see these displacements. The displacements are the effect of a force being present, and we can tell the direction the force is going in by the displacement of the buoyant effect. So helium balloons moving in a particular direction, air moving in a particular direction, shows us the direction the force is going in. You can qualify that by demonstrating it to yourself in any vector that you want. That's that's just physics.
You're saying helium balloons go up, and so therefore you can surmise that the Earth is going up because all direction follows the.
Yeah, and I can test that because we've done tests. I don't know if you can pull up Williams one with the helium balloon attached to the spring. If you could, Natch. So in the container of the box, the helium balloon stretches the spring, so the helium's pushed to the top of the box and it elongates the slinky. So you can see there's a buoyant effect. Now, when you release that box into free fall, the air has no compression anymore. So the only force present is the tension of the spring, which contracts, showing you that there's no buoyancy anymore because the force is no longer present.
Again, as soon as I put this container into free fall, you can see that upwards push, the buoyant force of the helium balloon within the air that surrounds it, again, is present when I'm holding it and it's connected to the earth. By the fact that the slinky is being stretched, obviously. When I put that into free fall, that upwards force, the buoyant force, completely vanishes, and the slinky retracts to its original shape. Showing that there isn't that upwards push in free fall anymore. Buoyancy basically vanishes. And it's instant.
Let me give the opportunity to Jeran first. In your opinion, what do you think is happening there? Like when you see this balloon actually falling, and then the
same
obviously
thing about the rocket, right?
Okay, yeah.
Right. So
which is what?
So the air is being pushed to the top of the box.
Yep.
Okay.
And thus.
Again, he's trying to say that it's not the slinky that's causing the helium balloon to go down. The tension of it. It's not that. It's the air is pushing it down. So you see. But the thing is, if you were to put a string instead of the slinky, with the helium balloon, and you released it, because again, the string's not going to have the tension that a slinky would if you stretched it. The string is not going to retract. When you release that into free fall, the helium balloon is going to remain in its position on top of the box while it's in free fall. Again, the only force present in free fall here with the slinky is the tension of the slinky retracting to its original form, because there's no force stretching it anymore. Because again, that's the only way to stretch a slinky.
Mm-hmm.
It's utilizing a force.
Mm-hmm.
So again, he's trying to say that it's the air pushing it down, like the land experiment, but no, it's not, because again, you could use the string instead of the slinky, and the air's not going to push the helium balloon down in free fall.
Mm-hmm.
Again, it's only because the slinky, again, it's the shape of the slinky and the tension of the slinky and the lack of force, and that's why it retracts and then basically pushes the helium, or pulls it, for lack of a better term, down.
What?
And so
what? I'm sorry. I thought you asked me what's going on here. So if the air is pushed to the top, then the balloon would be pushed down.
But hang on
Okay.
a minute. Hang on a minute, because earlier on it was a claim that everything's being accelerated downwards at the same rate, which means the helium balloon, the spring, the box, and the air within it should now all be accelerated down at the same rate. There should be no change whatsoever.
What do you mean? The air is dropped?
Earlier on when we were talking, you clarified and you made the statement that everything is being accelerated downwards at the same rate.
I never have said everything is being accelerated downwards at the same rate. So don't act like you don't strawman me and then go ahead and misquote me. I never said that.
I'm pretty sure if you rewind, that's what you said.
I said every item is downward accelerated.
So when I say there's no displacement of the accelerometer in free fall, you say that's because everything's going in the same direction at the same time.
No, I'm saying that there's no. If you're talking about, I was giving you the globe explanation.
All right. So what's the stationary Earth explanation then?
For what?
For why buoyancy and density all ceases in free fall?
Because whatever you are dropping, right? So in that case there, you're dropping the box, you're dropping the balloon, you're dropping the air, I guess, right?
Yeah.
Well, the air is being carried down with the box, correct? Is
Yes.
the air... Right. So the air...
And he can't let go of this down. The air is being carried down with the box. Again, there is no down. That's what these demonstrations are showing, that the force is up. I'm showing you that. So again, he keeps going back to this default position that there must be a down. And now he's trying to basically make all these observations and demonstrations fit his downwards bias of this magical force. Like, he keeps going back to that. It's pretty annoying. It's pretty crazy, man. Like, damn.
I would say so.
Right. Well, it's the same thing as the van. We just watched the van. The van pulls forward. The air, you said, is trying to remain in its place. Mm-hmm. So if you drop a box, isn't the air trying to remain in its place and the box is compressing?
So everything's not accelerating downwards at the same rate then?
Everything is accelerating downwards at the same rate.
If the air was...
because if he's claiming that compression is happening and that's what's pushing the helium, then that contradicts the claim of uniform acceleration in free fall. So again, he basically got himself right there.
I notice when he tries to buy time, he just repeats whatever Dow said last.
Yeah.
So it's like his little giveaway.
Yeah, he basically contradicted himself there.
Oh yeah, definitely.
Yeah.
Because if things are, according to him, things are supposed to be objects are going towards the ground.
Without displacement. Yeah. And now he's claiming that that's what's happening with the box. He's
trying to get Dow by saying that, but that's not even his stance.
Initial claim. It contradicts his initial claim now.
Yeah.
His explanation of what's happening with the box now. Mm-hmm. Which again, it all has to do with the tension of the slinky, but he keeps avoiding that. He says it's the air, the compression of air in the box pushing the helium balloon down.
To stay where it was. If the air was to stay where it was, so would the spring and so would the...
Here's what my question is, like the air that's next to my head right now. So you're saying that I think that the air next to my head is being accelerated downwards?
Oh, is it? What's causing the gradient?
I don't know, but it's not accelerating downwards.
So when again, when I've got an accelerometer, an air bubble rising through water, and a lead weight sinking in the water, and I let the vessel go and that ceases, the air stops rising and the lead weight stops sinking. You said earlier that it's because everything's now moving at the same rate towards the air.
Got you. So you're saying that the water should try and remain in its same position? Well, I guess my problem is there's nothing that's going to push the items inside the water in a different direction, right? So if you're dropping a bottle of water and inside of it are items, now the items right now, if I'm just holding up the bottle, they have density, they have weight, they'd be going down to the bottom of the glass. If I drop the glass, then everything is moving, the glass, the water in it, but the water is just hitting the top, right? So there's what's going to cause to go through and push the items somewhere? There's nothing.
That's the point. There's no force. But again, when the air bubble was rising through the water, going upwards, and I let it go, it stops on its ascent through the water, right? So it should be the same in the box there then, because in that example,
no, water doesn't compress like that.
Right. So when if I've got a standing bottle in front of me and there's an air bubble rising through the water, why is the air rising through the water?
Because it's less dense and the water's going down and the air's going up.
Right. So again, in the box scenario, that should be the same. The helium balloon should stay in its position because the air's still there. But now you're wanting to say, no, the air stayed still while the box all moved and compressed the air at the top of the box.
Yeah, but then you're saying that gas is the same as liquid, which I don't believe.
Gases and liquids are both fluids.
Okay, but if I have a glass of water sitting next to me, the water is going down. It's trying to get out of the glass going down, but there's a bottom of the glass which is preventing it from.
Again, how many times does he assert that there's a down?
The water's going down.
The water's going down. The box is already going down. like all like in his head everything's going down already. Again, like he cannot be more stubborn. Like, you know, again, it's either that or he's at it. You know,
Yeah, it's one or the other. It has to be. It's either deliberate
or he's
it's
just
daft.
yeah, it's crazy.
You making noise again?
Sorry, it's my partner coming into the.
Oh, I thought you were just making poof noise again. So I'm just saying, if I put a glass of water next to me, the water is trying to go down. But right now, sitting next to me is a glass empty. The air is not trying to go down.
So air's not going down, but we have a pressure gradient.
Correct. Yeah. Well, I mean,
Or-
I'm saying it's not going down because it's also all stacked on each other. Right? So there's air everywhere in this room. It's not like the air from the top of the room is trying to get to the bottom. It's just all the same weight. It's all the same density. It's all the same air. It's all the same collection.
It's all the same weight and it's all the same density, but there's a gradient, there's a reduction in pressure the higher we go.
Yeah.
It's not a homogeneous, you know, air. There's a gradient to it.
Correct.
Right.
Well, and it's also, but it's not just a gradient based on weight and density, right? Meaning that the air around us is nitrogen and oxygen or whatever. Argon, right? But I'm saying those three things have different weights. We don't have a gradient of all the heaviest gas at the bottom. Do we?
I don't know what you mean. There's just a gradient. There's a pressure gradient.
Okay, so do you think that the heaviest air is at the bottom of the earth?
No, the air's just air.
It's not made up of individual things?
Well, this is a whole other investigation. You know, I mean, you know,
Okay, well, sorry, that's what you were getting at. I thought you were trying to say.
No. I mean, if you know, you take these things like, you know, we talk about.
Is air all the same thing? Then you would understand why the air in my room is not trying to get from the top of it to the bottom.
No, but there's a gradient to it.
Okay, in my room?
Yeah.
Yes.
Well, no, not in your, well, maybe not particularly, not a small amount, but we do understand that you know, when you're at lower altitude, the air is heavier than if you are in the Himalayas, right? I mean, like that's true or not true?
It is true, yes. But I'm saying it's not a matter of which one is. There's just less of the collection of air, correct? At the higher altitudes. Meaning, what are the? I always forget. What are the types of gases in the air? Nitrogen, oxygen, carbon dioxide.
Yeah, something like that. Yeah.
Okay. So, but each of those has a different density, but they don't line up according to that. Which they would, I guess, if you had some sort of a either a gravitational belief or you had some sort of even a moving upward belief. I'm guessing. Why would it? Wouldn't you say? So, do items have? So the weight of items then is simply their ratio compared to the Earth moving up, or their. How would you describe that? How would you describe weight?
Weight is matters, you know, what we call inertia. It's its resistance to motion. So as the Earth presses upon it, depending on the rate of the Earth, you know, just like if you were on an elevator right now and that elevator was moving at 50 miles per hour, and you stood in a scale and say you were 18 stone, and I now start accelerating that elevator upwards, your weight increases because inertia is a factor of matter. So, you know,
and if we had a bunch of rocks in the elevator with us, as you accelerated it more and more, they would also organize themselves based on their individual densities or their resistance to movement.
Yeah, their weight would increase. You know, if we had a scale under them, then you would see an increase in what we call their weight. But the weight's not a property of the matter at all. It's a relationship between the resistance of motion and motion.
Right. So if the Earth is moving up, okay, good. I don't want to. Basically, that would be straw manning you because I'm just going to basically ask why doesn't the air separate out by the same way the rocks would? But it's because there's something called the cycle, basically the gas cycle.
It does. I mean, if you understand, Jeran, if you were in a swimming pool and you had a beach ball, you know through that experience, if you try and take the beach ball to the bottom of that water, you can feel the push of the beach ball. You understand that? Yep.
You mean the push up?
Yes, so imagine right now you're standing at the bottom of a swimming pool holding a beach ball.
Right.
You can feel that push upwards, right?
Correct.
So if I then had that swimming pool with you in it holding that beach ball, and I had it connected to 2 cranes elevated off the ground, and then I disconnected those cranes, and that now went into free fall, instantaneously that push that you're feeling from that beach ball ceases.
Wait, start again. So you said if I'm in a pool with a beach ball at the bottom,
Yep.
okay, and there's a crane pulling up on the beach ball, or what is it doing?
Well, just if a static crane, has a swimming pool elevated off the ground, right?
Oh, the swimming pool itself is off the ground.
Yes, and it's connected to the crane, which is connected to the earth.
Okay.
And as you stand at the bottom of that swimming pool, you can feel the push of that, right?
Yeah.
As soon as the crane disconnects the swimming pool and puts it in free fall, instantaneously, you no longer feel buoyancy. It instantaneously vanishes.
Okay, because when it's just hanging from the crane, then the water is much more dense than the air in the ball, and it's trying to get under the ball, which is what I feel pushing up. As soon as you disconnect the crane, now everything.
So Dale's trying to, again, globe earth rhetoric. He tries to say that the water or air pushing down or accelerating down somehow magically can push things less dense up. Again, which is the opposite of what physics shows. The less dense gets pushed in the same direction that the medium is also being pushed. But in his model, just like globe earth, the air and water get accelerated down or pushed down or whatever, pulled down. And then and somehow is able to also push less dense material up because there's a down. So again, it's contradicts physics. It's multi-directional vectors that doesn't exist, and again, just doesn't make any sense.
The water is going down, so the ball no longer has a bunch of water trying to get under it. Everything's going down together.
Right, so there we go. There's the clarification of that claim. Get back to the test a minute ago. Your claim is that everything moves simultaneously downward.
Well, not everything. The things that we're talking about. If you're talking about this particular example, when I say everything, I'm talking about everything.
He's literally saying it depends on what example you're talking about. In other words, I'm just gonna change my logic and my reasoning to fit whatever experiment you're showing.
Pretty much.
Like he's basically saying that my logic's not gonna be consistent. It depends on what video you're showing me, and then I'm gonna warp my explanations. Again, men's interpretations over physicality.
Yeah, he's essentially telling you, I'm going to be dishonest.
Basically, without actually saying it, it's fucking crazy.
That is contained within the pool.
Yeah.
Okay.
So just like the box experiment a minute ago, everything within there must now all accelerate downwards uniformly, like the pool example.
Except for the air is going to be pushed up against the top of the box.
Well, in that case, then the air should still push upwards in the swimming pool as it's into free fall.
So wait, is the swimming pool inside of a box?
Well, it doesn't matter.
It does matter. It's the same thing. If we open the box that was dropped, is it not different than when the box has a top?
No, we've done it with an open vessel and closed vessels. It's the same result.
What do you mean? How would you do that?
Well, we've done the tests with an open vessel and a closed vessel. The results are the same.
Okay.
So if you're in the swimming pool, right? Let's enclose the swimming pool in a box.
How would you drop a helium balloon in a box if there's no top?
Eh?
You just said that you've already done it without a top. So now go back to what's his name's example and show me that without a box, without a top.
Right. Okay. Fine. So getting back to it again, the swimming pool example. Now you've just stated it that when the swimming pool goes into free fall, the helium, the beach ball, and the water, and you, and the container, the pool, are now all moving at the same rate. Now, when we show you the test there of the helium balloon stretching the slinky, and we put it in free fall, you claimed then that the air stayed still and pushed the helium balloon downwards. So if that's the case in the scenario of the swimming pool, then the beach ball should still push upwards as you go into free fall, but it doesn't. So there's a problem in your reasoning here.
Okay, I'm trying to grasp what you're saying. So you're saying in the box example, we have a helium balloon tied to a spring.
Mm-hmm.
Okay, so it's tied to the spring because if it was okay, and you drop that, so now what if we had the air, the ball of air? Is it also using a spring connected to the ground?
No, if you're in the swimming pool, well, if you can put
Well, I'm just
yourself.
trying to make it like things, so we don't just say one thing is like the other if it's not exactly the same.
See, let's clarify where the problem here is.
Clarify.
When I gave you the example of the swimming pool and you holding the beach ball, right? And I said when it's released into free fall, you feel no push of that beach ball upwards. Okay. Then we go to the box example where we showed you the helium balloon in the spring. And you said the reason the helium balloon pushes down on the spring is because the air remained where it was. So that's given a buoyant effect, right?
Okay. Can you describe for me just real quick, just so I know what we're talking about? So in the box itself, what is the setup? Just remind me so I can think about it.
Well, Nat's just showed it there a minute ago.
Yeah, I just can't remember. So you've seen it more times than me. So I'm just asking you, it's a balloon attached to a spring or no?
Yes, it's a helium balloon attached to a slinky. And when you're on the Earth, the buoyant effect is present.
Yeah, I'm just asking the whole entire thing. Is that the only thing we have in the box? Just a helium balloon and a slinky?
Yes.
And then air?
And air.
Okay. And then in the other example, being held by a crane instead of being held by William is a pool.
Yeah.
Okay, with how much water in it? Half the thing of water?
No, we can fill it to the top. We can half fill it. We can seal the lid. We can have it sealed at the top if you want, whatever you want.
And there's a whole bunch of water. And inside there, instead of the spring, it's me standing there. And instead of the balloon, I'm holding a beach ball.
Yes.
Okay.
And you can feel the buoyant effect, the same as the helium balloons showing you the spring being stretched.
Okay, I got you so far.
Yeah. And now when I release that swimming pool, instantaneously you no longer feel the push of that beach ball. The buoyant effect ceases instantly.
It would just hover in the middle of the water.
Yes.
Okay. And then in the box, you're saying that the helium balloon wouldn't just hover in the middle?
No, because the only force that's present is the tension of the spring. So that as it's connected to the Earth, the buoyant effect overcomes the spring and stretches the spring. Now, when you release the box, the pressure gradient ceases instantaneously, and the only force present is the tension of the spring, so it contracts.
Okay, so now tell me what the problem is with those two scenarios, why they show anything, or why you think they show something.
No, it was in relation to when you said that when the helium balloon won, when we let that go, you said the air remains where it was and causes a pressure on the helium balloon to push it downwards.
Well, I was asking you because I was asking if it's the same as the van.
Yeah, well,
I wasn't making a claim. I don't know what.
Well, that's what I'm saying. If that was the.
In other words, it's not the same as the van. Again, the van is utilizing pressure of the air to push the helium balloon in the direction of acceleration. In free fall, that's not what's happening. Obviously, in free fall, the upwards buoyant force vanishes, and again, the slinky simply contracts to its original shape. So all we experience in free fall there is the tension of the slinky pulling the helium balloon down. You know, but yeah.
The case, then it should be the same in the swimming pool example. The beach ball should still be visibly moving through the water as the water in the swimming pool move faster towards the Earth. But it doesn't. It stays right where it was instantaneously as you release it.
Yeah, so to me, that just is a matter of nothing has weight then at that moment, right? Nothing has a weight different than the other item.
No, there's no weight to anything.
Right. Okay.
Because you need a resistance, you need motion in order to have that what we call weight.
Right. Weight is pressing against something.
Again, weight, you need a force, an external force, something else that's external moving towards another object, and then that object resisting that force, aka the other object pushing up against it. So you need a force, aka something pushing, and a resistance to the force. That's what gives you your weight. Yes,
you need a force. You need a force, external force acting, pressing against something to give you weight.
Okay, I don't necessarily agree, but I see where we're at. Okay, now explain what this should explain to me. Why did we watch that? What is the conclusion I should reach?
What do you mean the conclusion? What you should
Give
realize.
me 2 examples.
The conclusion is that objects don't accelerate in free fall, which is a default claim for the globe Earth and stationary flat Earth, which means it debunks the globe Earth and stationary flat Earth. So that's the conclusion of this whole topic. You know, this fact that there is no physical downward acceleration, it's the Earth's motion that creates all the effects here on Earth. You know, that debunks the whole heliocentric model, you know. So again, he's just trying to downplay that fact, you know, to, I guess, to make it seem like it's not important, you know. But
It's just odd that they're over an hour into conversation and he's like, so what is the point of all this? What am I supposed to get from all this?
right,
And what
over
is
2
it?
hours almost. But yeah, so what's
It's
the
like-
point? Yeah.
Where you're not participating? I don't get it. So weird.
It's like when Globe Earther, you know, you have them cornered already, and they're like, "Well, what difference does it make? Why is the flat Earth important? You know, it doesn't change anything."
It's like just when they agreed to, like, okay, the Earth is rising. Okay, now what?
Yeah, it's like,
How does my daily life change?
Yeah, it's yeah, again, it's using that same logic that Globers use, you know, when they don't have an explanation or anything to back up their claim.
Examples. You just showed me the balloon in the box. You showed me the pool idea. So now I understand it. I agree with you. So now what does that tell me?
Well, it tells you when it's connected to the Earth, it's experiencing a force.
When it's connected to the Earth, it's
Can I try to explain it?
You try,
I guess maybe. Okay, so like the way I understand it is that, you know, if the Earth is rising and everything that is connected to the Earth that is rising, it will create the buoyancy. But at free fall, buoyancy loses its effect because it's no longer "quote unquote" connected to the reference frame, which we call the Earth. And if you're standing, for example, on the Earth, and then you're holding up that bottle or that box, that helium balloon, that box with the helium balloon inside the box is connected to you, which is connected to the ground, which is moving upwards. Now, did I explain it rather adequately, or do you have something else that you want to?
No, I think it's quite clear. There's a correlation with being connected with the Earth and the effect of what we ccall buoyancy and density.
Right. Yeah, let's just make it simple. Yeah, go ahead, Jeran.
I was gonna say, it could be that it's too late. I agree with what you're saying, but I don't understand the logical conclusion that should come from it. Like what you explained has not said to me that the Earth is moving up, but you're saying that if I tried to describe this using relative density, that it won't work. Is that correct?
Yeah. So let me try.
No, hang on, Nat, because it's important in this part. Sorry.
Go ahead, you do it.
I just feel like this is really important because the relative density part is another aspect. So this is why I came to these conclusions and these tests. This was based on flat earthers claiming relative density disequilibrium. So relative density disequilibrium,
which I disagree with. Okay.
Yes, because that's the point. If relative density disequilibrium was true, then an air bubble rising through water is a relationship between the air and the water. That being that the air is less dense than the water, so it gets pushed upwards through the medium, correct? But, you know, that then should be the case regardless of whether it's in free fall, because the claim is it's a relationship relative to those two mediums.
Correct. That's why I abandoned that thought.
Yeah,
because
that's exactly why I done these tests, because I knew that you need an external. This is why the globe Earth has gravity. They comprehend you need an external force for buoyancy and density. So relative density disequilibrium should be there regardless of whether or not the apparatus is in free fall. Air should still rise through the medium, you know, regardless of whether it's on the Earth or whether it's in free fall. But the stationary earthers, in order to get round this, go to the position of that's because everything's accelerating equally towards the Earth, which is, you know, the same as the globe Earth rhetoric. But
which is the same as your rhetoric that the Earth is moving upwards.
No, because you know, I'm not claiming that in free fall things are being accelerated in a vector towards the Earth. I'm claiming that, you know, buoyancy and density are shown as the direction the force is going in, right? And then when we remove that from the Earth, you get an instantaneous disconnection. So the pressure's no longer there within the medium to displace the air to give us buoyancy. These guys are claiming the opposite.
Yeah, I know. I don't agree with them. I don't think relative density alone doesn't explain what we see, which is why I've always said Dell has an argument with Oakley and that crew, not with the people who say there's a downward vector.
No, my arguments with anybody that claims there's a downward vector. There's a gradient of electrostatics. I don't deny that. That's not the issue. But electrostatics cannot recreate these conditions.
They set them down. That's all.
How does it set it down?
That's all.
Because of the polarities of the Earth being negative and the sky being positive, and then there's a downward gradient.
Yeah, so that then, in order for it to be a direction, it has to be flowing in a particular direction. So
that's what all magnetics and electrostatics is a constant flow, isn't it?
But electrostatics is a static. What how do you get a linear flow direction from statics?
Any change, isn't it? Any change going to account for that?
No, there's a change in the charge.
Right.
How do you get a linear directional flow from static charge?
You don't get the flow itself is not from the charge. The flow is due to the density of items.
Right. So then, again, use electrostatics and accelerate these things in a different vector.
Okay, I'll run that by Zach and
I had journalism. I had a little tech chat with space audits. I can't remember. Is it
Alan?
I think it was Alan, and he came to the conclusion at the end. It's this simple, right? From my position, whatever this electrostatic, this background field is, right? It's my position that we move through it. Now, on the counterclaim, the counterclaim is that we are stationary and that flows through us. That's the simplest, way to put this.
Right. Okay, but that's kind of what I was saying by just the opposite. It's just okay. So now, why is one shown to be true and not the other?
Because in your case, that there has to be that downward flow, an acceleration flow from top to bottom. Now, when we do these tests of accelerometers and various other materials, we do not detect that. We do detect it when it's on the Earth, that being that the Earth's the thing pushing through this medium. So for me, it's the motion of the Earth. The two factors, the two constants, is the background constant, which gives matter inertia, and that's the resistance to motion.
But if things are going down, if the electromagnetic field is from the high of the sky, let's say it's a ton of volts, and then down to whatever it is at the Earth, which is a downward movement or a downward gradient, then how do we know that's not what's causing the pressure? Which would then be the measurement. Then accelerometers are actually using electrostatics to get your movement.
But then we're in a position that it's not detectable, other than optically interpreting it. Because
why wouldn't the accelerometer detect it?
Because when we drop the accelerometer, it registers nothing. There's no.
The reason why it wouldn't detect it is because it's not accelerating down.
Displacement of any matter. When there's a force applied, we get displacement of matter.
So you're saying that if we drop an accelerometer in air, it doesn't show that it's cutting through air?
Yes, it registers zero. If you use a digital one or you use an analog one, both register zero.
An accelerometer registers zero when it's dropped.
Yep.
Yes.
All accelerometers.
Yes.
Okay.
If you took a skydiver and attached an accelerometer to them, it would register zero.
What about if you're saying the same thing is true if you used a man-made one, a water bottle?
Water bottle. If you had an anvil, a huge anvil, and you by a string attached a water bottle, a basic accelerometer, and you threw that anvil off the top of a cliff, the water doesn't displace. The air in the water don't displace. It's not detecting a downwards acceleration.
Yeah.
Have you ever had a full cup of water, Jeranism, and you've dropped it, and the water stays exactly where it was?
Yeah. Again, I can explain that. I don't have any issues with that.
Yeah, I can explain it. It's because it's still on the upward trajectory. It's displaced in the upward trajectory. It's the reason why water's level. You know, this is another aspect of it. You know, water being level is the result of a force acting. Now, again, force is something that presses upon things. So the very fact that we have a world with water displaced, and we have a reference to that, which is the plumb, the vertical, that's how we distinguish when something is level. You cannot distinguish something as level without a reference to the plumb, which is the vector.
Okay.
So water being level is the result of a force acting. Now, again, I can change the orientation of water level by using motion.
Okay. So okay, yeah.
So I would assume Jeran's just speechless now. Like he's you know, the penny dropped and he's getting it now, right? That's why he's speechless, right? Right.
Imagine.
Right.
I guess I'm missing something. Maybe it's too late. I'll think about it and talk to Zach. Zach will usually be able to explain to me a little bit better. And then also, go ahead. I'll talk to.
I know you're getting ready to go, so I think it's good to just sit on it, and and then
let me talk to Alan and those guys that are a little bit more scientifically inclined.
Well, that's a bit a thing we on me by saying that, Jeranism. I've spoke to these people and they cite kinematics, which is the ability to interpret things from different positions. Now, again, the thing that if you're being genuine and honest, I would suggest here is that any of the claims should be brought into the realms of physics, which means demonstration.
Okay.
So they're going to just say the same thing as a globe says. The way they interpret it.
Well, no, I don't know, man. Like, I think it's good to just let people try to figure it out. I mean, like, obviously, I believe that you're speaking the truth, but if they're not picking up what you're putting down, it's not that they're being. It's not that they're being dishonest. It's just that maybe we have a disagreement about how things are working.
Well, I mean, the truth of the matter is nobody's ever changed their mind in a moment anyway. You shouldn't be expecting that, Del, if that's your expectation.
Right.
No, that's not my expectation.
Okay.
Again,
sometimes things need to be talked out. I kind of understood what you're saying, at least more than I did at the beginning. I do see some issues I need to figure out in my head. I can't really explain it. So I'll talk to Alan. I'll talk to those guys. If something is the truth and our model doesn't match it, I'm the person that's going to be voicing that. I don't want to have a belief that doesn't work. So if this is one of them, we'll figure it out.
That's fine.
That's fair.
I didn't have an expectation. I'm this very same. I started off my life as a globe Earth space believer, and then I went through a process of learning, different things to come to this position. I even had the opinion, Earth stationary and this, that, and the other, before, and I still had that resolve to correct myself and learn and move forward. So I don't expect anybody to get it in one go. I sat on this and went through this process for about 2 years before I actually came out into the open with it. So I don't expect anybody. The only thing I really expect is honest discourse. If people are claiming that they're honest and they're truth seekers, then we should be able to have these discussions.
But the problem is that if somebody has a certain idea in their mind and you are changing that idea and then basically expecting them to acknowledge right then and there, that you're going to have bad luck with that.
No, I don't. I've just clarified that. I don't expect that.
Well, it seemed like you did, but anyway, that's fine. Give me some time to look at it.
I thought I clearly explained there that I don't have the expectation. My only, my bar of reference is physics. So all claims in any claim must come into the realm of practical physics for me. That's just how I operate. I don't go on beliefs. And if things can be practically demonstrated and satisfied in that regard, then I accept them. That's it. It's as simple as that for me.
For me, I guess the problem that I'm having with it that I don't quite grasp is that you can't remove the conditions of the earth. You're saying, I can make things go left, I can make things go right. Yeah, but you're not removing what's already here. Not at all. There's still the downward direction, whether it's gravity, whether it's electrostatics. You're not.
Again, he goes down. He keeps going back to this downwards vector that's there. It's like just shows that he's not being honest with himself. It's kind of annoying. If I'm being honest.
You're not removing that. You're just acting within it.
No, what I'm removing is the claims of physicality. The claims that things like, gas, liquids, and solids can accelerate simultaneously without any displacement. That's a pseudoscientific, claim. That's
What do you mean by displacement of what?
Gas, liquids, and solids. There's no force known to man that can accelerate gas, liquids, and solids without displacement occurring. That's not reality. So when people claim that, then I have a problem with that.
Okay, you're saying because there's only one thing that does that, and that would be the things moving towards the Earth.
Yes, that's a special pleading. It's the same as the globe Earth. It's the exact same claim. Well, the only difference is that they've removed gravity and replaced it with electrostatics.
Yeah, and the reason for that is because gravity is their only answer for why things are spheres. And when you get rid of that, things wouldn't necessarily need to be a sphere anymore. That's why we've gone that direction. It shouldn't be that difficult to figure out.
A thing that you might want to consider, Jeranism, is when you look at the globe Earth from that position, things form spheres only in free fall. They've taken no force acting. The background thing, whether it's electrostatics, ether, whatever anybody wants to call it, it's that's responsible for water forming spheres in free fall because there's no active force acting on it. So their axiom is taken from free fall. And that's why they try and derive a force acting equally inwards towards the centre of that sphere. That's where they've taken it from. But when it's applied, when things are connected back to the Earth, that's not the axiom. That's no longer present.
Right.
Because
Something else.
Yes, water displaces when it's in that position. So their axioms from free fall, no force acting while they're trying to claim a force.
Correct.
This is why
we have to be free falling around the sun, and why the sun's free falling around the galaxy, et cetera, et cetera.
Yes. So they ignore. They don't use the word ether. They say gravity, gravitational fields, gravitational this, that, and the other. They're talking about the same thing that other people are talking about in regards to ether. There's something that gives rise to matter and gives matter what we call inertia. And in the state of free fall, like water, liquid forms a sphere. So they're trying to extrapolate from that position, but that doesn't give you a vector. That's something different. When people are talking about vectors, we're talking about active forces. There has to be an active force present, which is why they get round it by saying it's a force, but it's not a force, and they've got loads of double speak.
Right.
But the fact of the matter is, when true force is applied, we do get displacement of materials, of matter. That's just the facts that people can deny if they like, but it's not going to change the reality. It's just a matter of people understanding where the assumptions, where the axioms are being derived from. As I say, my axioms are derived from practical physics. Theirs are derived from theoretical physics, that being making mathematical assumptions on things and then deriving, their interpretation from that assumption.
Okay, so just so I get it, one last question. So if we drop something from the Empire State Building, is it increasing in speed on its way down?
No, it's losing momentum.
Same question.
Again, same question. The change in velocity is a deceleration. Again, in his head, it's an acceleration. That change in velocity can only be an acceleration. I mean, if that doesn't show you have a bias, I don't know what else. You brought it up like, I'm not even lying, like over 6 times probably. I'm not even exaggerating that number. Wow.
See if I can just give you one example in order for you to understand this, right? If you're on the Indy cars, right? If you've got 2 cars,
I didn't hear that. Yeah, what?
You watch IndyCar racing or Formula One or anything like that.
IndyCar, yeah.
So imagine now you've got these 2 cars that are going round the track, and there's 2 cars, and there's a gap of 1 meter between those 2 cars, right? Okay. Now they're on a straight, and the car in front reduces its speed to say 90 miles per hour. Then see that the car behind has an impact that's very, very subtle, very slight, but they're both moving still forwards. Now, if you increase the gap between those 2 cars so that the car in front now has more time to lose the forward momentum, the impact is going to be greater. Do you understand? But they're still both moving forwards.
Yeah, okay, got you, because the car coming behind it's going to be moving much faster compared.
Yes, but they're both still moving forward. It's just that the one in front loses that initial momentum. So the impact's greater. The more distance you have, the more time there is for the car in front to lose its forward trajectory. So the bigger the impact is. Now, if you were standing outside observing that, you could interpret that the car in front started to go backwards. and that's the difference. It's a visual interpretation. Both things are still moving forwards, but as the gaps increase, the one in front has more time to lose its momentum, so there's a greater impact.
Okay.
So it's the same when you drop something. If you drop something from 10 centimetres, there's a very slight impact because the object has not had enough time to lose that initial speed. If you take it to the top of the Empire State Building, it now has more time to lose that speed, so the greater the impact when the Earth comes to meet it.
I understand the impact part. I'm not really sure I understand the speed, but I'll think about it.
It's just because it's visual. As I say, with
Again, the impact is because of the change in velocity. Again, but it's not the acceleration of that pre-falling out, it's the deceleration again.
the two-car scenario, if you observe that optically, you could interpret that the car in front has accelerated.
Let's let him go, Del. He's been wanting to go for like 40 minutes now, and I do want to thank Jeran for coming by, and thanks for having this conversation. And I'm glad that we were able to, talk like gentlemen for the most part, and if we can avoid calling each other names, like especially on panel. I don't care if you do it like on your channel, that's fine. I mean, that's part of content or whatnot. But like here, when we are having a serious conversation, let's try to be cordial as much as we can. I know we are going to disagree about stuff, but that's just the way it is. So again, thanks, Jeran.
Thanks, guys.
Go ahead.
I was just going to say, I think that's a massive part that's always been here within this whole community, is that anybody that has a differing, view or comes with something different, automatically there becomes this defend-attack relationship, which I've never really understood. I think the problem comes because of my mannerisms, my accent, my appearance, that may play a role in this attack-defend thing. For me, it's supposed to be an objective inquiry. And anything that I say I can qualify, it's not about, usurping anybody and becoming top dog. I'm not involved in any ego battle. The only hope that I have is that we can continue these sorts of open discourse, and we can progress from that. I don't have a gripe with anybody. I don't have any personal relationships to anybody. I don't have a horse in any race. As far as I'm concerned, we should be able to objectively discuss. If there's tensions, sometimes people have to look at their own position and why they're being defensive of that position. If it's true, we can discuss it and we can practically demonstrate the things to each other, and it's as simple as that. Another thing I just want to throw in there, maybe that will take your interest, Jeranism. You know how the globe Earth proponents have behaved towards flat earthers over the years. You know that, as far as they're concerned, we're dumb flares. And they'll take any opportunity to make hit piece videos and jump upon anybody that they think's making outlandish statements. Would you agree with that?
For sure.
Have a look, Jeranism. How many globe earthers have responded to this position of mine?
How many what?
Globe earthers have responded to this position of that I have.
I don't watch them, so I wouldn't know.
None. The problem is because they know that I comprehend their model and they comprehend exactly what I'm saying. And they know that if they dare enter into that discussion, they're going to be made to look absolutely ridiculous. Because for me, and I'm going to make the statement, it's a fact, there is no physical downwards vector.
So, I have a debate platform. Why don't you challenge some of these globers then?
If you can get a glober to come on and talk specifically about gravity, and you can moderate that with respect and blah, 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 fine. Again, I'm going to say that as long as everything's qualified by physics, by practical reference, and it's no opinions, it's no beliefs, and it's proper science, that being, physicality, physics, demonstration, isolating variables and changing and altering them, then fine, I'm willing to step up for that. But I'm not going to enter into a discussion where it's purely rhetoric and these people don't have anything to qualify their position. I don't want to waste my time and my energy on, hot air.
No, I think that if you did do debates, though, and it's a timed thing, then it's going to show if you're able to bury their arguments or bury their position. So
yeah, that's fine. If people need the debate platform, that's fine. I mean, all these tests can be witnessed on my channel, Williams and Andrew's channel, that there's been a plethora of
I would say that the main problem I've seen is the people who have come to me, there's 5 or 6 people who have come to me and they can't explain it at all, right? Yeah. They completely are just basically saying, I think Del's right. And I say, okay, explain to me why. And they say, I don't know. I think that he has a point. They can't explain it. If I would do anything, if I were you, I would try and work on helping them be able to better convey what you're trying to say.
That is the problem, Jeran, and not everybody's gifted with the ability
No, I know that.
communicate.
But I'm just saying that if you, maybe it takes like, and you already have this. I don't watch your channel very often, so I don't know. But if you have like a nice, comprehensive, like maybe 20-minute summary, where it can be better, because you have to realize. So when flat earthers hear the Earth is moving upwards, they pretty much tune out, right?
Yeah.
So we're gonna have to get something to grab them.
Yeah.
This one here with the box and the helium, that's the one I've drawn out here on my iPad here, because I want to look at that. That kind of grabbed me, so that might be a good place to start.
Yeah.
Because you're right, there's something wrong there. I can't really work in my head. I was, yeah. So anyway,
it's funny that you mentioned that, because for me, that's the propaganda that was done to flat earthers. As soon as flat earthers arrived on this scene, that's immediately the first thing they were met with. The Flat Earth Society are controlled opposition, and the reason that's given for that is because they say the Earth moves upwards. Now, I asked that question, and I would ask you the question: where's the Flat Earth Society's presence been through this whole decade? It's not been anywhere.
It's really gone.
Yeah, it's not been anywhere.
And they took that down, I heard?
Yes, they did. They removed it. Yeah.
Yes, I heard. Which I did think that was the first thing that made me go, that's weird.
Yeah, because and now on the Flat Earth Society page, they claim it's stationary.
So they didn't used to, huh?
No, but obviously since I started bringing it forward, funny that they've removed that now. But as I say, I would ask people that question. Don't let the propaganda affect you. Ask yourself the intellectually honest question.
Let me ask you this intellectually honest. Do you believe in a creator?
Of course.
So do you believe the Bible?
No, I'm not religious in any way, shape, or form.
So would it be important for us to know that we're moving upwards? I mean, what would be the so if God didn't tell everybody that, does it really matter?
I mean, God is telling you that through physics.
Yeah.
And it is important because it destroys the whole heliocentric model. So the Earth's motion, in my opinion, the claim that object accelerating in free fall is the biggest lie on Earth, because without that lie, the globe Earth doesn't have a leg to stand on, So
it matters in regards to the topic of the Earth's shape, because if you establish that the Earth's moving linearly, then that's an absolutely impossibility for a globe Earth to exist. It's over. The globe Earth. That's why I asked that at the very beginning. The globe Earth cannot even get off the drawing board without a physical downwards acceleration. It's impossible.
Right. And I've always, that's why I think that they have to hold on to gravity, even if it doesn't match observations, because there's no other explanation for the downward or the pull to the center.
They need it to explain antipodal, people standing on a globe Earth and water or sticking to it and yada yada.
Right.
It's a requirement. Without that, it's absolutely impossible. For linear motion to be happening on a globe Earth, it would tear itself apart in a very short space of time. It'd be over. Yeah. So, it's the equivalence. That's all that they've done. They've taken natural phenomena and they've interpreted the natural phenomena in order to fit the model, which is, downwards acceleration. And if you look at all other examples, all it is visible interpretation. They have no physics. Nothing.
Yeah, I know that. No. All right, well, we'll talk again.
No worries. Cool.
Later, guys.
All right, good night.
Peace.
All right, later, Jeran. Yep.
All right, I think that was it for the conversation. I think I'll end it off with the demonstration video I did last. Why? Because this is how easily you can debunk the globe Earth and the motionless flat Earth. In other words, downwards acceleration. You do it by falsifying the claim that there's no physical downwards acceleration by the fact that there is no displacement. So again, by debunking that there is no physical downwards acceleration, you by default debunk the globe Earth and the stationary flat Earth. Not only that, the fact that buoyancy, again, measured with test and repeatedly, is an effect of a contained system that's in motion. Again, buoyancy showing you the direction of the force. That also shows you that the Earth is pushing up. So I'll end it off with this video. Okay. Video, I'll be doing two different density and buoyancy experiments. I'll be recreating density and buoyancy in three different vectors utilizing motion of a contained reference frame. In the first experiment, I'll be using a container with water, a red ping pong ball, and a steel ball. The ping pong ball and the steel ball will always displace relative to the direction of the force that's applied. For example, when I accelerate the container to the right, the container pushes the water in the same direction, creating a pressure gradient. The water is then able to push anything that's less dense, like the ping pong ball, in that same direction. That is what we would call buoyancy. However, the water is not dense enough to push the steel ball like the ping pong ball, so the steel ball remains in the same position. The steel ball only appears to move in the opposite direction of the buoyant force because the camera is also moving with the container. The ping pong ball has true motion and the steel ball has apparent motion. The same principles apply when I accelerate in any other direction. In the second experiment, I'll be using a tube with water, an air bubble, and a steel ball. To accelerate the container down, I will be using a resistance band. As you can see, when connected to the earth, we can experience a force creating density and buoyancy. The air bubble is being pushed up and the steel ball appears to move down in the opposite direction of the buoyant force. You can also see the air bubble is flattened where the force is being applied. However, when I release the container into free fall, density and buoyancy completely vanish. The air bubble is no longer being pushed up and turns into a sphere, showing that there isn't a force present in free fall. When I actually accelerate the container down, we can see density and buoyancy invert. The air bubble is being pushed down and the steel ball appears to move up. Not only does acceleration require a force, acceleration will always cause displacement of solids, liquids, and gas, proving that objects don't accelerate down in free fall.
Fair enough.
All right, so that's going to be for this one. Again, reality shows you what's really going on, and anybody claiming otherwise without any practical demonstrations or references are just talking shit and are full of shit. And yeah, they shouldn't be taken serious. So, any final thoughts?
No, I mean, without proving he has the patience of a saint.
No, yeah, that was a long conversation, and yeah, a lot of circular reasoning, a lot of just faulty reasoning, and yeah, I do give them props for having the discussion. And yeah, I guess this is going to be it for this one, and we'll see you guys on the next one.
Yeah.
Peace.
Take care.